cook, I sometimes follow recipes, but then I have leftovers from those recipes. What do I do with that? I don't throw those out, right? I maybe put them in a soup the next time, or in tacos, or like I put in a sandwich that I talked about earlier, right? So I think about really more, the way I think about it is like, okay, some starch, some protein, some vegetable for dinner, right? And I put those together and kind of make them taste good. And sometimes that doesn't turn out great, and sometimes it turns out great. But I very rarely make the same dish twice, actually, as a result, except for when I do fall, yeah. So there's always some variation here. The other part is, this is my kitchen. Not everyone has this kind of kitchen, right? Some people have smaller kitchens. Some kitchens don't have ovens. I never use my oven in the summer, or I didn't used to, because I live in Seattle and we don't have air conditioning. And when it gets hot in the summer, I can't use my oven. My house is going to be impossible to live in. Let's see. When I was a kid, this one time, I have to tell this story because it's just so cool to me. I went to the small Greek island for my fall vacation with my parents, who were Greek professors. Anyway, we stayed at a friend's house, and we went to the local bakery, and there was a whole oven in the back that the bakery did not bake bread in, but actually everybody brought their casseroles and their pots to the bakery and paid, a small fee to the baker. Hey, can you bake my casserole? And then they'd come pick it up later. And that also is some form of a way to feed your family, right? Like that. So be aware of the constraints that you have. Use your community resources. Pool together and learn how you think about this. So, all right, enough of the detour. Here are some of the components of a platform. And I am, yes, going to compare them to cooking. Because again, this is something that almost all of you are intrinsically familiar with. And before I joined tech, when I joined tech as an adult, I definitely tried to think about some of these concepts in the terms of experiences that I had already had. So it's very, very valuable to think about these systems in a more general sense. How do systems work? Not all systems are technological, but that doesn't mean those lessons don't apply. So, first, we have ingredients, right? When we're cooking, we got those tomatoes, we got that basil. Sometimes we have staples, right? We always want to keep oil in our kitchen. Some ingredients are fresh. They will go bad. Like, we can't, store those tomatoes forever. Like, we can't eat those next week. Sometimes we can't find certain ingredients, like basil is best in summer. Some ingredients are super expensive. Like, mushrooms have been getting really expensive. It's super bummer. I love mushrooms. So I thought, if I think about that in terms of what I do with my data on my platform, right, I have to think about, how do I store it? What kind of data is it? Is it my customers' data? Is it my metrics data? Is it just simply all the information that I need from my users to help them, right? Is it like configuration data? That is also important data that I need to build a platform. And, how expensive is it to store that data? Where do I store it? Can I always that the availability stuff is in there, because sometimes I want to have cold storage for my data because it's just long term. Sometimes I want to have it available in a cache really quickly, right? When in that famous interview question where they're like, design Twitter or whatever, you're like, yeah, I need to build a timeline, so the data needs to be there faster. So those are always just kind of the things you have to think about. Right, so long-term fast access, slow access. And I just kind of put a few examples out here. These are not all the same things. Some of those are, outright databases and database solutions. Not all of these are open source. Most of these patterns have open source solutions, with a possible exception of, compute, which we'll talk about next. But, I put CSV files down there because that's a way to store data. I put JSON down there because that's a way to store and organize data, right? So whichever one of these tools is a best fit for you and your situation, right? Sometimes you might have super weird constraints, like we need to make sure that corporate approval to use this technology, that it is safe and secure and has passed vetting. So you might not be able to use any of this. You might be locked into some different solution. This is why I'm not being super specific. This is why I'm being very general here. Look into it. Look into what you need. Ask people. Ask the internet. But this is a little bit like what we're talking about. You can store data in a lot of places, it turns out. Next, equipment for cooking. How do I turn my data and my ingredients into like something that can be eaten? How do I ship? What do I use to make all of this real, right? So, you know, I was thinking about this in terms of compute. We need to actually churn all this information and like make the app run, right? So stove, oven, like these are all ways to think about it. Honestly, this is like my weakest comparison here, so don't squint too hard. But yeah, we have compute, we have servers. They need to be powered. We need to like interface to these servers. How do we talk to these servers? Where, you know, right? Like not everybody is like super excited to SSH into a server and do stuff in there, right? How can we make that palatable to people that, you know, where that just isn't in their toolkit, right? Because those people are shiny unicorns and know how to make a website that look really, really cool, which I totally don't, right? So here are some of the ways in which you can make sure that compute is available to your platform users. Again, there are some enterprise icons on here, mostly because those are just some of the solutions. This weird one right here, actually I don't have a pointer. The blue one with the bubbles, that's actually GitHub Actions, because it turns out you can run a lot of compute on free GitHub Action runners. People mined Bitcoin on them for a while, and that was a problem, I think. So, but also, you know, what's the hardware you're running on? What operating system are you using? These are all real concerns for when you have your compute up. Cool. Next, what is the event? So, when, like how, and under what circumstances do we actually want to ship to production? If our app is broken, we don't want to ship, right? And we can help our users with that. We can like make sure that like we have tests, we have CI, CD, we have gateways, we have canary deployments, where you only deploy to a few resources or a few users. And if those break, then you have a signal that like, oh, whoops, maybe we need to fix it before we ship it on the whole. And so these are all of the things that you can think about, right? When you're planning for an event, you want to make sure that you know what you're shipping. You need to make sure what for, right? Is it a big release with a blog post, or is it just like a little bug fix? How many, you know, how large? How large is your production environment? How many people are you shipping for? Right? Like, how many servers do you need to run sales on Black Friday, right? You got to know that. That's basically a thing you have to think about. And again, here are some solutions. This is mostly about the moment when you hit deploy. The Kubernetes icon is on there because, you know, kubectl apply is absolutely how you ship your things. It's open source. It's available to you. GitHub Actions is a good way to gate your deployments. There's Argo. There are some tools. This is called GitOps by some, where you let the status of your code in Git determine whether it is ready or not to go to production. And there's lots of tools that can help you with that. I'm happy to answer more questions after the talk if we have time, just to go into a little bit of detail for that. Next up, we want to make sure that our app runs in production as we expect. We want to have metrics, right? Like in this case, you know, if we think about it, was the food on time? Did the food taste good? Did anybody die eating it? Or have like a massive like allergic reaction? Thankfully, there are no food allergies in my family, so I don't have to really worry about that super hard. But you know, those are things you wanna ask maybe before you. So anyway, so those are metrics. You want to gather metrics for every stage of your deploy. You want to gather metrics on the state of your servers. You want to gather metrics on, you know, maybe even the state of your data. Right? Did we deploy successfully? Did users engage? Also, how much time did we spend building all this, right? Was it hard to deploy? Did somebody have to, like, you know, fly out to a town and pick up a suitcase full of data sticks and like fly back to another town and plug it into a server? I don't know. That is probably you don't want to do that, right? But cool. So here are some metric solutions. Again, some of them open source, some of them not. I see someone with a Grafana T-shirt here, so I feel super glad that I picked that one. I put PagerDuty on there because that's what happens when your metrics go sideways and then you get pinged at night. But basically, this is where you store your logs. This is where you have your dashboards. This is where you know the state of your production system. And again, you want to build this in a way that your developers can use it, right? You want them to go to those dashboards and realize, oh no, I'm seeing too much traffic, or like something seems weird, or, right? Because they know their app better than you do. You just built the platform. Finally, safety, right? I talked a little bit about, like, did anyone die while eating your food? You want to prevent that, right? Like, by the time you get the metrics on, like, oh no, somebody died eating a mushroom, it's too late. It's too late. You want to have practices in place. I am not a huge security person, so please attend security talks that are not here, that are not mine, I mean, to get more information on this, but do consider it, right? We want to make sure that, you know, we secure our data, that our environments can't be hacked. We want to make sure that everybody who interacts with our platform can be trusted. And we want to prevent incidents and breaches. So I put some, you know, there's a key value store on here. There's again, you can use GitHub to like lock down who has access to your repositories. There's a little icon down there with a teacher. You should educate everybody that uses your system on how to do so securely. Security training is a big deal, right? You can also hire a team, right? Large companies do this. They hire a team of hackers to see if they can like break in, right? That's just some form of like security testing. So these are things that you should think about and collaborate with your security experts on, so that you have this piece of your puzzle. Great. Okay, so that was the components. Let's see. I'm going to quickly walk through a couple of examples and then leave time for questions at the end. My first example is when I was at GitHub, I maintained the internal deploy platform there. We called it Moda. There's no reason. It was just a name. But basically, let's start with the data layer. The data component, from the perspective of us, was not so much all the data that GitHub churns, because there was a whole data team to deal with that over there. We just needed to make sure that our apps could connect to it. And we really didn't do much, but we did need the data of what are the apps, who's deploying them, where do they live? And so basically we took care of that by saying your app has a repository on GitHub. Your microservice is a repository on GitHub. Then our platform was bare metal Kubernetes clusters. That's basically it. We had multiple clusters, and we had load balancing between clusters to make sure that we had greater uptime than a single cluster would have done. Next, in order to deploy, it was basically just kubectl apply under the hood, but GitHub had a big thing with chat ops, so you would basically go into Slack and tell the robot to deploy your app. And the robot would know what to do and forward it to kubectl, and then your app would go to prod. Deploying github.com was a little bit more safeguarded than that, but this is basically what it boiled down to. For metrics, we used a couple of enterprise solutions, Datadog and Splunk. Splunk for our log storage, Datadog for our alerts. There was a quick experiment made into using the ELK stack with Elasticsearch for metrics. I don't know that took on, and then we all got PagerDutied when stuff went sideways and somebody ran kubectl namespace delete dash dash all. That was very fun. And then finally, our security was basically who has access. And yes, I am not kidding you, but the security team, at the time at least, had access roles in a big, was it a YAML? I think it was a JSON file or a YAML. I can't remember, but your roles were scoped where basically your username was in that, in the security repository. Again, super boiling this down. But yeah, so there you have it. You have the repositories that are scaffolded in a certain way to allow us to deploy your application onto Kubernetes. Actually, you can deploy it yourself because we built the tool for that. And then we are also providing metrics and alerts, and we lock the system down by not allowing anyone that doesn't work there to have access to the GitHub repo and to have access to the production environment. That was locked down to my team and several other teams on, like, sister teams. Yeah, but so that's like a big enterprise solution, right? This is when you're in a company where you have a team, or you have the ability to have a single team that can just manage the platform for everyone else. That's not everyone's situation, right? Like, what if you're running like just a small, scrappy startup? What if you're consulting and you just want to have like some basic systems to like repeatable patterns to pull out of your sleeve? What do you do then? So that's kind of my current place. So yes, I work at Pulumi. I promise this is not a sales pitch. This is just an example of what you do when you want to have some of these components not baked for you by a dedicated team, but if you want to basically just like pick and choose, get them piecemeal. So what Pulumi is it's the way, the part of Pulumi that I work on is infrastructure as code. You write a program, you run the program, and it deploys cloud infrastructure for you. So you can ask Pulumi to get you an EC2 instance or an AWS Lambda, or is Cloud Run an Azure thing? I think it is. And Pulumi can interface with all of that for you, which means that your teammates might have an easier time, again, deploying things because they don't have to go to like the AWS website and click around for role permissions. You can write a program that does this for them, right? So that's basically the form of templating. You can write a template that will work for most people at your company, and then hand that around. And that's we call that a component, but really most of what it is, it's a reusable piece of code that can be written in a programming language of your choice, that you can then hand off to people and say, hi, this will like deploy the infrastructure that you need to run your app somewhere. Right, so that's how you deploy compute resources. Pulumi 2 has a command line tool. With Pulumi Up, there is the option to do CI/CD integration with Pulumi deployments. However, that is unfortunately not open source. And then again, for metrics and alerts, there aren't any. It's kind of like you bring that. You can bring that yourself, right? So this is really more of a composable set of tools that you can use to build your own developer platform. Similarly with security, if you want to stay open source, you bring your own. So yeah, that was a whirlwind tour about some concepts, some examples, and just I want to encourage you all to think about these patterns in the context of which other really complicated systems that you have in your life and that you know how to solve already. So, yeah, I think we can do questions. I will probably turn this mic back on and hand this mic to run around if y'all have questions. But thank you so much for coming. I hope this was helpful.
All right. Any questions from the audience? Thank you so much, Guinevere. Got a lot of recipes cooking now, so. Questions?
I think one of the challenges for me thinking about developer platform is that like a lot of developers can be also opinionated in terms of like workflows that they've done. Different languages, different tools, you know, and different frameworks require different flows. And balancing that, like trying to maintain a standard set of like interfaces feels sometimes challenging. And so like finding that balance between like saying yes to cater to everyone's workflow and preferences to like limiting, avoiding like too much like sprawl. Like
Yeah. So for those who, did you all hear the question? Perfect. Yeah, so that's a really cool insight. And for me, this comes down to who are your customers? Are you building a developer platform for someone who's paying you? Or are you building a developer platform for your colleagues? Because if you're building a developer platform for your colleagues, it is possible to, make rules for them, right? Making those rules and enforcing them is going to be easier if your platform is easy to use, right? But there are going to be moments when you need to actually feel empowered to say, we can't do that for you. You should try it our way, and you will get the same results. And if you truly cannot get the same results doing it our way, then come back to us and talk. You can do that if you're an internal platform team, which was my situation at GitHub, and it felt really great. And did we solve the problem for everyone? No, we didn't. It didn't work. It's never, no platform, as I said, is ever going to work for anyone. When somebody is paying you, however, you don't have that option. And again, I speak from experience. That's my situation at Pulumi, right? We don't do this to like run some giant like code sharing platform somewhere. We do this because other people are paying us to create solutions for them. And so yeah, that's where you have to be really smart, because I think you can still push back. And if your product is very, very good, you can say, please try it our way. Right? You do have to listen to what people need. But you're right, a lot of people get like really tied up in the details, and they're like, no, but I do want to use Haskell though. And it's like, sometimes it's actually okay to say, then maybe we're not the solution for you. But on the other hand, it's like, okay, well how about YAML though? Can you maybe do that? Right? Because maybe you can translate it to Haskell on your end, right? It's a tricky line to walk for sure. This is, but yes, I would always say listen first, come up with suggestions. People want to be heard, and make sure your platform is easy and intuitive to use. Yeah.
Thank you for the talk. Is this on?
Yep,
yeah,
it's
okay.
on.
Perfect. You had just mentioned that the platform should be intuitive and easy to use. And with some platforms, they inevitably get more complex as time goes on, because you have all these edge cases that need to be handled, and it has to be flexible in certain ways. And one of the big challenges when that starts to happen is discoverability. Like how you don't want people having to go to a Slack channel and say, how do I do this, right? You want them to be able to find the answer quickly.
That's
on
right.
their own. Like you don't want that element of friction in the platform. So in your experience, like how have you thought about solving that discoverability issue, and just in general, that aspect of making sure the platform is easy to use and intuitive, and people don't have to go chase other people around to find out how to do what they need to do?
Right. You're going to hate my answer. Everybody hates my answer. And the answer is, you must have excellent docs and keep them up to date. Like, I'm sorry. Like, seriously, use AI tools to keep your docs up to date if you must. If you really hate writing docs that hard, then again, if you hate writing documentation this hard, I don't understand where you're coming off wanting to write lots of prompts all the time, because it's basically the same thing. So those were a couple of hot takes. But yes, discoverability is right, and you need to have the docs also be structured in a way that it makes sense to people. It's not just have docs. It's more like, no, your docs need to like get started. Start with the base case, you know, then have like footnotes. Hey, if this is your situation, you might want to use this. Or really, if this is your situation, then come talk to us. But like good documentation is the first stop. Next, I think, you know, you should have some troubleshooting pages. Your docs should be searchable. Honestly, one of my proudest docs accomplishments was writing a really terrible JSON index-based search for the docs site, and everyone's like, oh, thank you, it's so much better. And I'm like, but it is so jank. It doesn't even like reload after you ran a search. You have to like reload the whole website to get a new search box. And everyone is like, it's fine. It's fine, this is better. So yeah, so that's documentation, but you can also make the tool itself like be really easy to use. One of the things that worked for us at GitHub was that everybody was already used to using ChatOps all the time. So using ChatOps to say, you know, hey, Hubot, deploy, kind of felt like you could almost discover it organically. So yeah, sorry, no secrets.
What business-facing metrics do you think are useful for justifying a platform team?
Ooh, honestly, I've never been in a place where I've had to make that decision. When do you want to run a platform team? I mean, as with anything, it depends, which is sort of the cop-out answer. But I do think that, honestly, I would look at what amount of time your engineers are spending on ops, right? If they're spending more time on ops across the board than they are on anything that has to do with new features, you might want to consider a platform team or like one SRE person, right? I feel like as soon as your developers are spending time on things that like don't make sense for them anymore, that's when you flip. And it doesn't have to be a big team. You can also go, you know, the like takeout order route and order your food. You don't have to cook your own food, it turns out. But you know, you can pay someone, right? I don't know, Heroku used to be really great at shipping stuff. Pay them, for example, right? Depending on your situation. Yeah. Yeah, I think we have like one more question. Yeah.
It's working?
It's on.
Okay. Yeah. Yeah, I really liked your comment on the documentation. Self-serve usability is like how you measure if your platform is good, I think. But I saw in some bigger companies that they build platforms and they become really, they become tech debt, or sort of,
Yeah.
where you know you have great engineers building that, and it becomes really integrated into the company. And as they ages, and the industry has better solutions,
Yeah.
it actually becomes a burden. What
Yes.
do you think about that?
Ooh, that's always right. I mean, similar story, right? You have to stay on top of things. You have to be. I have not figured this one out because I've often been in situations where it's like, oh, clean up this tech debt. I had to learn about Capistrano in the year of our Lord 2019, I think, because it turns out there were some Capistrano things running somewhere deep in the bowels of our system, right? So this is so real. It is, unfortunately, this is honestly the biggest reason to not go into any kind of platform engineering or DevOps, because maintenance work does not get rewarded the way that feature work does. It never does. It is true in public as well. When was the last time that a politician got elected for keeping all the bridges from running and not collapsing and not killing people? That never happens, except lots of work actually goes into making sure people don't die in like buildings and bridges that already exist. Same story, unfortunately. So the real answer I think here is work for someone who recognizes the importance of maintenance work and sets aside time to eliminate tech debt, because it's always going to happen. Yeah, it's not a good answer. I'm like, make sure your leadership is aware that there's a calm duck on the surface of the pond and it's paddling really hard underneath. Yeah, anyway, thank you so much. This has been really fun. I will be at the conference all weekend, so I'd be happy to meet some of you and chat. Please forgive me if I forget someone's names. I've met a lot of people. So thank you so much.
All right. All right, well, thank you all for being here. The next talk will be at 11:15, and as a reminder, Cloud Native track is happening in Ballroom A and Ballroom B. All right, thank you, everybody.
That was a different ballroom, I believe. Test 1 2, test 1 2. La 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 la. La 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 la. All right,
Check.
so I'm not
Check,
getting
check.
a channel.
Check,
in.
check, check, check.
Test 1 2, test 1 2. Oh, it's because our levels are all the way down, maybe?
It should just be this aux return send, but maybe.
But if it's coming out the master, wouldn't we also need to crank the master volume?
No, these ones, it's not coming out the master. It's coming out the aux. So this aux return right here is the control for the volume for this aux return.
Ah, okay.
But maybe we can try it.
Test 1 2. Oh, that did it. Yeah.
That one's going through. Yeah. And then keep talking.
Yeah, test 1 2, test 1 2. Da 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 da. Okay.
Yeah, so we have to have the master out, but then this is what controls the
Yeah,
volume.
that's the volume. Cool.
And that was the one they were having trouble with?
It was, just go ahead and test that, because what you get on your board is a balanced feed from us. So it was the whole room was quiet. So if you can test that one real quick, make sure it sounds nice.
Check, 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 check.
Check, check,
1 2
check,
1 2.
check. Yeah, it's balanced.
Check,
so,
check.
Yeah, cool.
Okay.
All right, so I'm going to turn up the aux return just a little bit. There we go. Those of you in the room, how does this sound? This sounds okay, yes? Cool.
Testing, testing, testing. Oh, that seems nice. Yeah, that seems okay. They're fair. So, this is the mic. It goes over your left ear.
Oh, okay.
Yep. If it doesn't stay in place, they've given us some medical tape
Okay.
so that you can actually stabilize it. But you'll
Okay.
have to see.
Okay.
And then do a few tests.
Test. Yeah.
Okay.
Yeah.
Okay. So Testing, testing.
Test, test. Hey, everyone. Thanks for coming. I'm Justin Garrison. I'm one of the organizers of Cloud Native Days LA. If you are in this room for, I think it was called Who Broke the Build, that talk is not happening. So they could not come. So it's what was in the printed schedule, but online and in guidebook. And I think on the sign outside it says the wrong thing. We do not have control of all those things. They all happened after that talk did not happen. So just so you know, if you were here for that, that's not it. You have a wonderful talk instead from Khalees Hightower. But first, I want to give one quick shout out for our sponsor from Minimus, Adam. He's going to give you a real quick thing. Everything here at SCaLE is volunteer run. This building, the food, everything does cost money, surprisingly. And so we do rely on the sponsors. So just wanted to give a real quick shout out. They get to talk in front. You have a table out front for minimizing. So I'll take it.
Awesome. All right. I'll be quick. Adam Clark, I'm at Minimus. At Minimus, we build compliant by default minimal container images that are meant to be as vulnerability free as possible. We do this by shipping purpose-built images where we build from source continuously. So any change that's checked in the code from an upstream open source project that whether it's functional based or vulnerability based, we basically check those into our own code, our own universe, the same day they happen, and build images within the same day that they happen. So at the end of the day, you end up with images where if you compare them to their public sources off, their public repos, they're generally 97% to sometimes 100% reduction in vulnerabilities. So the whole idea was, how can we further help continuous remediation of CVEs by just reducing what we put in from the beginning. So if anyone wants to hear more on how we're doing it, he said we have a table out and we'll be at SCaLE in the exhibition hall all weekend. So thank you.
Yeah, and thank you very much for sponsoring. This is very great. So with that, we will turn it over to Khalees for, you are a full-time student at University of Washington, and excited to have you part of the community with Cloud Native and learning this whole experience. So.
Well, thank you. Okay, yes, the mic works. Okay, awesome. Well, first I just want to say thank you for coming out, or at least in this room. I will say there was a little part of me that thought it was just going to be me and my mom and my dad just right here. So this is great, definitely more than that. And if anybody has known from the rendition that I did 2-ish months ago, there'll be a little bit of similarities here. So if you didn't catch that one, this is definitely a good way to be able to see some of the content there. But then there's also some things that we're building off of that. So just wanted to give y'all that preface. And then when I first had the opportunity to do this particular talk, it was back for a meetup, and it was back in January. So I'm just kind of going to run through how I kind of came to make that first part of it and why I even got into Cloud Native to begin with, so what sparked that. So I was in conversation with the organizer of, it's like Cloud Native PDX it was, so shout out to them. And she was saying like, hey, would you want to do this? You can talk about literally anything. She said, let me see if we can go here. Specifically, yes, any topic that you'd like to present around Cloud Native and Kubernetes, which was awesome. It was open, it was free. She was very flexible with me, again, much appreciated. However, there's just a slight issue with that, at least for me, is just I had no idea what Cloud Native was or what Kubernetes was. And that's exactly what the conversation or the talk was supposed to be about. So I kind of felt like I was at not even square zero, but like -1. So of course I did the natural thing that you do when you have no idea of a topic or what's going on. I told her that was perfect, and I would get that over to her by the end of the day and wrote some abstract that I was just going to have to pray that I could come up with in the next 3 weeks, which is when the talk was. That's okay. That's okay. We pushed through it. So I was like, I better get a start on this. Like I put a really big time limit commitment for myself. So first start was probably to ask, hey, what is Cloud Native? Can I just put that into the search bar, see what comes out, just to see what I'm getting myself into. And I got a couple different answers. One was there's no one-size-fits-all answer. That answer changes depending on who you ask, and that really varies based on case to case. And I don't know if you've ever learned something new or done anything new and you just see just vagueness right off the bat. I was really, really scared to move forward, and I already had something typed up that was like, I can't do this anymore. But it's okay. Kept going through, and then I was able to kind of start diving into some general videos and then get my own consensus. Because that was consensus from other people, so I needed to make my own. And then what I did find, everybody seems to agree that being on the cloud does not equal cloud native. I said, okay, I can get behind that. And there was about 4 other topics that was, or I guess conclusions is a better way to say it, that I gathered from all these videos that I was watching. And the first one was to keep in mind was the architecture of it. So actually, how do you think about and break down applications rather than being holistic, it's just the app. Because before this, in classes and everything, you built the app, maybe you're learning the language on how to do it, and you deploy it somewhere, hopefully somewhere free, with a very long domain name, and you just kind of keep it out in the world. So this was kind of a topic that I was going to have to struggle with digesting. The second was containerization, and remember here, I'm just trying to look and lay the land, so I'm not quite diving deep into what these mean yet, just kind of setting a base. So containerization, so these parts of this architecture seems like they need to be packaged up. And it's like, okay, that's something I can get behind. And then container management. So it's like, okay, packaging those up, and probably need something to manage all of them. So right now, I'm following, I'm good, I'm here. And then the last one that I kind of gathered was like continuous development, continuous integration. So kind of, which the way I was able to do this for myself was very independent, but I still liked exploring what this might look like in groups and for other things and other ways that this might be used in industry is what we say in classes. So, but I guess that's really just anywhere. So this is what I gathered. This was my conclusion. So now that I had this, I was like, okay, it's actually time to get going. I have this thing to do. And he mentioned that I'm a full-time student at UW, and the first thing that students do, my generation does, is when we don't know how to do something, is we go straight to ChatGPT, which is exactly what I did. I typed this exact prompt verbatim into that. And if you can't see in the back, it says, can you build me a cloud-native app? I don't really know what cloud-native means, but I have a talk to give. My dad's going to be there, and I'd really like it to think that I'm doing what I'm doing. So make it sound really impressive, and then entered. And then I was finished. So that is actually the duration of the talk, and I hope you guys have a good rest of your day. But of course, that wasn't the way that it was used. Now, however, I did use some form of AI, but not in that type of realm. I asked it for a blueprint. Like I said, I have no idea where I'm going. I have no idea what to even think about. So I'm taking this with a grain of salt. So I'm sure everybody out here has their own 7-step, maybe 7's too little, too much, of how to actually get this done. But I just needed something on paper so I know how to move forward. So build the application, containerize it, orchestrate, add whatever this cron job situation is, deploy to AWS. Okay, I've heard that before. And then configure some public access. So yeah, I'm already like, okay, you know what? We're just going to take a break. I know how to do step number 1. Is build the application. That's what I can do. And that's what we did. So step number 1, let's actually go back. She should play. There we go. Give her some time. Okay. And then kind of while this is running and why I sparked this, you can tell I was having some front-end issues. As you can see, this big new shred across the front, just to see if I could test to see if something was coming back up. But I am a senior, actually, at the University of Washington studying informatics. And right now in my life, there's a lot going on. You know, I have classes and capstone, applying for things, finals, just everything under the sun, honestly, is how it feels. So when I realized that I had to make some kind of application just to test these concepts on, I was like, I probably should do something that's a little bit beneficial. So what is happening here, I know it's already changed from green to yellow, is kind of a burnout score. So you started when you're studying or doing whatever it is that you might reach burnout with doing. Let it go, the score goes up, and then as the score goes up, it's indicating that you're getting closer and closer to burnout. And then it'll change to red and everything. But creating this as this visual reminder of like, hey, it's kind of slow down. Because I think right now everybody's telling me to go fast, what's next, but I just needed something to almost penalize me for going too fast. And then when you take a break, it kind of starts to go back down, not as much as it increases, but just some standard logic. And then of course when you press end, then your session is over. So nothing too complicated, just a quick little front end, back end situation, but I just needed that base so I can understand kind of how to build off of these topics on here, right? So following that, let me make sure it's pulled up here. Following that, okay, that's when steps 2 through 7 had to come into play. So I actually did have to start learning these words that just felt very, very foreign to me. And then at this point in my journey, I'm gonna call it a journey, is where I had my first hurdle here. And I seek out usually videos to watch for guidance on how to learn things. I'm a very visual learner. And I kept getting things like Kubernetes everything in 5 minutes. 5 minutes to cloud native. And then, of course, Docker in 5 minutes as well. If anybody here knows why 5 minutes is the golden time for learning something new, I would love to know that. And a little part of me was like, awesome, this is great. I'm going to pretty much be finished in 5, 10, 15 minutes. So this was awesome. But then I actually clicked into what these were, and it was a different vibe than I thought it was going to be. It was essentially saying, like, there's a lot of words of, skip that part. We're just kind of going to roll over this, and you'll get to know this later. So I'm just like, okay, I feel like I'm missing a lot of parts here. But they were just saying, if you're able to do steps 1 through 4, you'll be good to go. And the thing I had to realize is good to go for them means that I could have ran or deployed whatever they were trying to tell me to do. But good to go for me was understanding, and that's where our expectation gap was there. So it was interesting to see that. It was hard to get. It's hard, so stop it for myself. So I had to start typing in things like the long, extended version of whatever it is I was trying to find to actually get to something that was a little bit more concrete, that wasn't afraid to go deeper in fear of turning me away. So, but it got done. It got done. I'm okay. And then we moved on to Docker, our friend. I also just really love the logo. Very cute. And what probably familiar with on this side, at least I would hope so, it's just kind of, the standard Docker file there. And then another kind of, I'll call it a fun fact about myself, is that I love to cook. It's something that helps me unwind. Yes, we have a fellow cook in the butt. Yes, it's something that helps me unwind, and then you get something good to eat out of it. So, it's a win-win situation for everything. So when I saw this, I essentially saw a recipe. And, me and my relationship with recipes are a little bit interesting, because I could write one. I could. I have not. It's just because it's so hard. There's a pinch of everything, something of this. I don't know what I'm putting in. And it's really difficult when I go home and I cook for my family. And they ask every single time, like, can you please, please, please write a recipe down so that we're able to recreate what you're making, this dish, when you're not here. And I was like, okay, that makes a lot of sense. That recipe never came. Sorry, guys, it's not going to. But it was at least helpful and beneficial for me to connect this back to what it was. So when I'm learning something new, I always try to do my best, if possible, to connect it to something that I already know. And then it feels a little bit more intuitive. So I got these Docker files going. It's great. I basically feel like a cloud native engineer right now. I'm good to go. And then that kind of all went down, just tanked all the way down because it was time for Kubernetes. And I had a lot to front with that. It was just a lot larger, and I definitely knew I couldn't do it all in 5 minutes. So I had to kind of go back to the basics and understand the things that I need to do. That means typing in the long version of things and all the things that it would take for me to kind of get videos and tutorials that felt good for my learning and that felt comfortable enough moving on to the next step. And there's a couple things that I gathered was, one, kind of containers being this runnable unit. Like, okay, I can work with that. I see that. And then 2, pods and deployments, running and maintaining your app. And I will say the first thing that I saw this about, they said that pods just die. I remember when I first talked about this, why on earth would we use something that just dies? I really had no idea why this made any sense, but I was just at this point just like, I'm sure it'll come up. So that's running and maintaining our app. And then we have this service to essentially, just because these things just keep dying, having this stable network inside of our cluster. I was like, okay, I'm starting to see the layers and how this goes. And then for this case, we had ingress to control access from the outside world. Again, very boiled down, simplified, but that's kind of what I gathered enough, again, to move forward. And then this is kind of this, again, another summary: deployment, service, and ingress, how many, how they stay alive, how traffic reliably reaches them, and how the outside world gets in. So we're good there. And the next thing, I don't know if you remember from the 7-point steps, was it said I was supposed to be adding crons to my thing. And at the time, I thought that was the next tangible step. Here now, that was extremely unnecessary and definitely not something that you just do for a simple application. But I did it anyways, and I don't regret it. Because I actually do think, maybe call it a hot take, but I do think that kind of doing something unnecessary for a simple project can make it seem less scary when it is necessary for a bigger project. So I played around with it, and it what did I end up making a change to? I think I had it where the timer, the way that it increased to burnout was a lot faster after midnight and then until 6 a.m. So that was kind of something that added there. Again, nothing too crazy, but it kind of helped me at least understand that there's other ways to configure these files. So far, the only command that I had in my Docker files was just to run, so seeing this to go into a different file and run a different command, which is something I wouldn't have known without going down this extra long rabbit hole of a path. So I respect it. Maybe not gonna see me anytime soon, but I respect it and I'm here for it. And it was a part of the journey, so it's here. So then it was like, okay, we're breezing through this list at this point. I'm good. And then I kind of go on here. It's like this feels like my last step. It was Amazon, AWS, EKS, whatever it was there. And then, I've deployed a couple things. Or this is, at least in my brain, this is the next step of hosting. And I check. I'm a college student, an 18-year-old college student for that matter. So, we have some costs to think about. So that was just the first thing that I asked. It's like, hey, what's that going to look like? And don't have to read it all, because I didn't. I just saw 72, 74, and said no. So it was not for me. I did no more exploring. So if you guys know of any type of secret cheat code way to have got it down, let me know. But at the time, I didn't have time to find out, and I didn't. So now move over, and today was DigitalOcean. So we switched over, and because this is something that I've heard my dad talk about a couple times. So I was like, okay, I'm familiar, I'm comfortable with making this pivot. But this is kind of where the next hurdle for me kind of came in, and I was so close to the finish line. This was like, I want to say 6 out of the 7 that it was time to be done. And I kind of went back to some of the learning practices, if you even call them learning, that are reinforced in school and what I'm told to do, which is opening chat, and I said, hey, I'm at the finish line. I just made this big move from AWS, and now I'm at DigitalOcean, and I just really don't have the time. I did all the good stuff. I'm basically prepared for the talk. Can you please just finish it off? And I'm sitting there, It's just error after error. Error, copy, paste. Why is it this error? Here's this fix in this circular loop. And I was there, and I was just like, it was telling me to put things into the terminal that just no way was necessary for this minuscule of an app. And I knew it was time to put the computer down and just completely restart after. It's not verbatim, but this is pretty much what it said I needed to do, was to completely get a new computer and restart the entire thing, and then it would work. So I saw stuff like that, and I said, okay, I have to sit it down. It's this, and I actually am appreciative almost of that part of chat or AI in general being just so ready to give any answer when it doesn't have one, because I can spot when that answer is not the one for me. So I said I put it down. I came back the next day, and I said I'm going to get back when I'm ready to learn. And that wasn't even the next day. It was the day after. I had to set time aside to actually be open to frustration. And I did. We got there, found tutorials and the videos. I did it the long way. And I still use some of it as a way to reinforce my learning. So nothing, it wasn't out of the box completely. But I got there. We were good. We're okay. And I just put that there because something about seeing your application on a different device other than your local host just make it feel a little bit more official. But we were good. We had it up and running, and had something I could see and I was proud of, right? And then I just also wanted to add this in here because I have this all written down in these nice bullet points and things like that. But this was really me. Honestly, I think in the talk I said a week before, but this was really the night before. Just trying to figure out what the hell did I just sign up to talk about. I still don't even know, and I have something working, which is interesting because I had to make a lot of sacrifices. So I guess I sold out a little bit at times. Where it's just it was too hard to find the long answer, so I had to settle for the short answer. So I tried to go back with the time that I had to figure it out, and it worked a little bit. I'll give myself some credit for it, but it was there. So, but with all of that, I at least knew that I could go from this to this, which it looks the exact same. It looks the exact same. And this was really, really challenging for me because I was, a lot of the times I'm like, is it working? And then I'm, this is where I do use chat a little bit. It's like, hey, this is what happened. Did I break the entire thing? And nothing's showing up. And it's like, that's exactly right. And it's like, okay, I can't do anything with this. Because when I first started learning how to code, getting into the tech realm of everything was really visual. It was, we had Scratch and putting things together, having little missions of what it needed to do. I think I had hour of code, not an hour, lots and lots of hours, I fear. But we had things like getting Elsa to the other side of the ice castle. It was just lots of things that made it seem like if this, then it does this very visually. Even like when you're learning like HTML or web development or something like that, it's still very reactive in terms of when you do something, there's an output. And that's what I was used to. This was so frustrating for me because I was waiting to see like at least some type of congratulations. Now I can talk to Ingress. Like, I don't know, it's just something. And it just never happened. So I just had to do a lot of trust. And it's only trust because I didn't get the in-depth answers that I had. So it was faith at this time. But I appreciate it, and I know where the things are, and they're there. Not even hidden anymore. So I kind of was able to see that not only does the application that I made look the same, and that's actually a good sign, but it actually works for the better for other people and outwards of me. So it's thinking less about myself and about other people, and that's just a hard thing to do, period. So, in tech or not. So I'm there, and then I was able, I'm finished, I'm good, I'm confident. So now if somebody were to confidently ask me, what is cloud native? I would, be able to say, it depends, and I still don't know. But this is where I actually was able to stop in January. I stopped here, and I kind of just let it go back in my brain. I was able to finally close out my VS Code so it didn't break. It was great. All the tabs were closed. It was very freeing. And then this talk came around, and they were saying, hey, like, this is something that you could do, and you have an hour time slot instead of 30. And a little part of me was just like, okay, I'm just going to talk really, really slow, because I do not have time to fill this up. And of course, free trip to LA, like it was dope. But then I remembered how frustrated I was going back and trying to learn this. And I said, okay, I have time now. I already have a basis of my slides finished. It is finished. I could stop here and tell you all to go to lunch, so I could have been done. But I decided to take this time to dive in without pressure, because there's a difference between learning for production and learning just for personal understanding. So I wanted to switch into that mode, and then that's kind of what I did. And then the next screen I'm going to show, don't get overwhelmed, we're going to break it down. But this is how my brain worked in drawing it out. In high school, I was always drawing things out. It was kind of a thing that my notes were just so clean and great to reproduce that any open note test, I would have to print out extras to give out to people, even though they should definitely be writing their own notes, but they paid me for it, so I wasn't going to let them in on that. But this is kind of what, for me, I said, take a break, take a breather. I know it's a lie, we're going to dive into it, but I just kind of wanted to zoom out for a second and show that this is really what I spent the last, again, I should be saying 3 weeks, but I have a lot of things going on, so a weekend, maybe a weekend and two, just polishing it up and trying to lock in on this, was to just draw out the flow. What's going on from the application that I had all the way to it being done. And then there was a couple of things that while I was drawing it out for me, because before I didn't have all these sticky notes, so if you're reading ahead, don't. That'd be a secret. I started drawing it out. It was all just for me, for personal learning. And then I was like, and this, every time I kept writing, I was like, I wish that this was here when I was doing this. Now that I understand and I'm reproducing, I really wish that this way was taught this way was taught this other way. So when I'm writing these, I said, I think that could be the second half of my talk, is that I'm essentially just going to say, this is how I wish I was able to be taught when I was learning these things. And in general, it kind of turned to how just teaching in tech in general could be transformed. And then I loved this, by the way. This was so fun. That's why when people ask, what do you want to do, what do you want to learn, I say I don't know, not because I have lack of direction, but because I'm in this stage of my life where learning anything is fun. I don't believe there's a such thing as not, what's the word I'm looking for? It's just always a need to learn something new. It'll come to me later. So I had a lot of fun with this, and I would just see myself doing this inside or outside of the office at any time. But then there was a couple things that I took away while I was doing this that I felt like is important to reiterate. So the first thing was to do the why before the how. And then just a couple bullets will go here. And why this is important, so it sets a foundation of care. And I'm going to go again through on this on the part of my drawing that has this laid out. It establishes a connection with the product or the process that you're trying to teach. And it starts small, and starting small before over-explaining. And then it also sets that base to appreciate the deeper explanation, right? So let's go back. We're going to zoom in now. So if it's staticky, let her cook. She's okay. She's okay. Okay. So this very small piece of things is the first thing that I found out was missing when I was learning. Is it went straight into this is why, it was the wrong why actually is how I'll phrase it. It was why this product is the fastest, why this product is the best, how it does this in the code, in the terminal, but yet to zoom back out and why you even need a product like this at all. So if somebody had came up to me and was just like, hey, your application is done, do you want it to be scalable? I'd be like, well, yeah. Do you want it to be able to be independently deployed or independently updated? And I was like, yeah. Easier deployment and all these things. So listing out the benefits just to start. Because then what that does is it allows when you're going in for more information, if you're trying to spark more information, you already have a base of like, I kind of care. Maybe not a whole lot, but I at least want to find out more on how I could get that. And then when you have it there, then that's when you can bring up a very simplified version of things. And again, it'll expand to get something to technical. But when you have this simplified here, and then basically this little box is all the drawing that I had. And just here. So the app, break it down, package the app, have those parts, manage those parts, set it up so they all talk to each other, and then, of course, having it so that the outside world can input in. If you see any typos in here, just kind of refrain your eyes. Like, this was a hard sketch. If this was like, all tied together, then those would be fixed. But, so having that there, so now we have the why, and then a little bit of like, almost like a sneak peek of what will happen. Because I do believe in seeing the whole picture first before diving in is very important. So that was kind of the first one on that end. And then the second thing was bringing up was like making the invisible visible. So what I was talking about, what was so hard for me for this one was that there was something to see. There's something to be reactive. And that's fine for what it is. The actual thing and the tool might be invisible itself. It's a process. A lot of things happen in the back end and things like that. And I'm not trying to knock on what it is. But that means that you can add it in the way that you teach it. And that's the thing is humans thrive off of visuals, period. And getting back to the learning of basics is something that I feel very, very strong in. It improves engagement, it enhances comprehension, improves memory retention, and that's all these things that when you watch a fun video, it's an engaging video, it's visual, and it's showing these things, and it's a cognitive thing of you connecting those dots ahead of time. And just because it is visual doesn't mean it's watered down, which is something that I feel like was prevalent in what I was watching, is that in order to make it seem like you know what you're talking about, it has to be as bare bones as possible, terminal, or you in a whiteboard and writing it down, which may work for some people. I'm not knocking it, but I think there might be some hesitation of being able to learn from something that's cartoonish or just not from a textbook, right? So when we have visuals here, going back, zoom back out, and then this is where I decided to put my visuals. This is my take, okay? So, because Kubernetes for me was the hardest one that I had to digest, so I needed to make a way that it made sense for me. And that's, we have these containers here, This is the way I'm kind of storing it out. But I did a roll call. So I have characters for all of these, for all the parts of, or the major parts of Kubernetes that's there, right? So we have our, let's see, what is this here? Yeah, like an API server. I call this like the worst game of telephone ever. Scheduler, we have that as our matchmaker, matching pods for what they need to do. This is everything. And then just kind of having all of these different visuals around made it make more sense to me. Because also when you're able to simplify something yourself, that likely means that you know it better as well. So it's not only good to reproduce, but it's good for yourself. So I would say get a pen and paper out. It might be helpful. And then down here, especially this like type of circular process for that control manager. Just having that there, reality versus want. Is that the case? Well, then fix it. So the circular motion. So now when you have this in a shape, and just as simple as a shape of a circle, you can kind of see how this is, not only did you learn that the control manager is always on, it's repetitive, it's always checking, and then it has this continuous update. So instead of just listing those out, just put a circle. And nothing's lost in translation, but it's something there. So now when I think about this, I literally have a mental circle in my brain, right? And then same for over here, we got like some traffic lights, warning signals, just maybe also did want to draw a little bit. But in the end of the day, having something here that's easy to refer back to, I think we actually have down here another little process of our like stable, these just dying off pods, and then all get going here. So that was kind of, that was that take there. It's two more. Because when you have this here, this is a visual. It is a visual. However, breaking those down individually and having their own type of thing. So there's a separate thing between making something visual to explain it, and then just simply showing the visual of how it works. I know that's a little weird, but it's there. So it's like, this is fine. And I'm sure for most, if they had the background, this is more than enough. However, in my opinion, now that I have my little characters in my brain, and then you put them here into this holistic visual, because you don't stop there. This is all in addition to what's already out there. Then you can have this situation where it's holistic, and you can show the overall flow and not lose them. So you don't get lost in things. So this is good. But, I say have this same creativity when it comes down to the parts themselves individually. Give them their time to shine in a way. Right? Okay. So then the next thing was teaching in workflows and not solely on infrastructure blocks. Right? So back here, technically what I did was visualize them as their isolated blocks, which is a way to do them. And you need to do this eventually, of course, to explain how things work. But I feel like it stops there. And then it's like, okay, and it leaves you to put the pieces together yourself. But I found that most of the time, I'm the kind of person in class in high school that was like, I kept asking why, until eventually somebody had to explain to me how the sun was created. Because I couldn't, it's hard to stay in isolation without trying to connect to something else. Again, it's another human thing. You reach for something to connect it to, a broader thing, an analogy. So if you just work in isolation, it's really hard to connect those dots. So by having that there and then making a very clear transition to how are these actually work together is very helpful. And then you can actually see we get back into this, I still know my code, I still know my language. This is here, there's no visuals. And it's, we just kind of have it going here to the request. I can't read that from sideways, but I know what I wrote. So data is stored, and then we kind of just keep using and following it all down to what a request might look like in between. I think this is like, to apply a file that we wrote. And then kind of going down. So we're able to use these keywords or underline because we've set not only care, we have context, it was engaging to get there, we know them in isolation, so then when you bring them up in this fashion, which is how it would be moving forward in the rest of your life and industry, you understand it. Because it's like, okay, they said control manager, I have a little circle going on in my brain, but I'm able to still read this and we're right on the same level. So how you get there is, I don't know why that's such a stigmatized thing, but we can get here. And then going in workflow, so then now you're able to put pieces together. It's like, okay, I see my individual, I get how it works. Could you probably have put them together yourself? Yes. But seeing it all work there is going to be key. And then a similar workflow over here, just about a general outside request coming in and what that would look like for there. And that was always what I was asking, how, okay, great, but why, what does it do? And then I kept trying to does this do this? I'm making the connection myself and I'm just lost. So there's rabbit holes that we can avoid if we just lay them out, if we have them, of course, but just lay them out. And then the last thing, which I think might be the toughest for people, is, this is just kind of refresh. Reinforces the importance of the component, allows the user to see the whole picture, and creates more opportunities for them to really get it. And this one for honesty. I don't know if y'all saw in this around here. It's a little bit zoomed out, or zoomed in. Come on, guys. There's these overall little light writings all over the place. You don't need to zoom into them because they're very much from the brain. And all they are is commentary. It's commentary throughout. When I was actively learning for myself to draw these out, I was writing what I thought it was, what it ended up being, and here's what it is. And this is might be the most important one because nobody wants to learn from a cocky person. And what I'm noticing when these questions are asked, when things are being presented, it's trying to impress. Like, hey guys, I know this so well, and here's exactly how it's done, and it was the easiest thing for me, so it could be the easiest thing for you. And it almost disconnects trust with the person who's teaching, because you actually have to invoke that. I trust you, not only because you invoked some care, but I trust you that you also struggled and failed. That's who you really want to talk to, somebody that's real. And then answering those questions, answering more questions without them having to be asked, because it unveils hidden knowledge. So if I'm in there, let's say I go through the whole workflow and everything, it's great, it's awesome, and I have some takeaways, but when you learn anything, if there's not a connection made explicitly, you will make it for yourself, as you should. That's how we work. That's how we keep things stagnant. But if you actually go through your process, you might have unveiled a connection that they made that might be wrong. And then it's like, oh, but you said it out loud. You didn't what's the word I'm looking for? You didn't make them feel bad for asking the question because they didn't even have to ask it. You just being vulnerable and being like, you know what, to be honest, When I started doing this, I thought, I don't know, we could do something else. Like, why have to think about the architecture in my thing? If you just say it breaks it down, okay. But it's like, you know what? I don't really know why. Because I'm like, there's so many things. Do I break it down into files? Do I break it down into just every single line of code? But then it's like, oh, no. But then I realized it's more about responsibilities and what it does and breaking those down. Okay. Because, see, I would have been worried if I went on and be like, period, I know how to break things down and package them. But then I might be packaging every single file, which makes no sense. But because I was able to say this honestly, now we are able to fill in some gaps that aren't there. And then this is more of a general overview of what so then I did this, right? And I kind of sat back and now I'm just observing. So I have my thoughts, and then I just sat. I sat in my classes. I came here, actually still evolving yesterday, or any type of tech conference or meetup that I've been to. I just was remembering and creating my own analysis of what I found. And it's not beginner friendly, and it's not because of the code is hard or the things that we're learning is just extremely difficult. It's just asking questions seems like a sign of weakness, and that's truly how it feels. And I'm even noticing in conversations that I'll overhear is that there'll be two people, they're meeting for the first time, and they'll just be like, hey, how's everything going? And they might ask a question about what they're doing. They might just, just to spark a conversation about maybe the work they're doing, and immediately is giving defensive. They have to just, almost like they're always advertising what they do, but it's just a conversation. But it feels like there always has to be a guard up so that nobody believes that you are unintelligent. And then of course, the conversation ends up being bleak because no one wants to have a defensive conversation when it's just supposed to be casual so that it doesn't happen. So and then when people do teach, it takes it as an opportunity to prove what they know and not to help the other person understand. So like I ask somebody and they sit there and I'm like, hey, I don't know this thing. Can you explain it for me? And they're like, oh, absolutely. And they just try to use all the biggest words that they remember from the textbook. They try to do all the complex things that they had to remember, and then they put it in front of your face to be like, I know what I'm talking about. Great. I still don't. So it's just there's this gap here. And then I've written this out, where first off, innovation cannot exist where curiosity isn't welcome. And right now, I don't feel curiosity is welcome. And for a couple reasons. It's fast-paced, where everything is being learned to produce. And it's almost nobody's fault for that one, because that's what I had to do. I had to produce something in 3 weeks. So yeah, I'm not asking as many questions because I don't have time to ask them. Because we have things that answer them for us, when AI comes, we can think that we have those answers quicker, then that means we set deadlines quicker. And then no one asks questions because I guess you don't need to, right? So we only start providing surface level information, then the parts of technology that actually spark passion and creativity get cut out because there's no need for them. We can just do without it. Then asking questions becomes more stigmatized than it already is. So then I'm just going to stop asking them altogether because really, do I need them? I produced a thing. Maybe I got the job or whatever the trick was that I needed to do. And then they settle for more shallow understanding. And eventually, the drive to change, create, and innovate will disappear. Because think about anything that's been changed or had a great milestone or has had any type of big innovation, it's because somebody challenged what was already there and was passionate enough and curious enough to find a better solution and a better way to do that. But that's not going to work if I go to chat. Chat gives me an answer. I copy and paste that into my code and I go. Because not only do I don't have a personal stake in what I just wrote, so I don't care enough to even digest it to find out if something's better. And then even if there is somewhere that I could make it better, I actually don't really know how because I'm only staying on the surface level of things. So if no passion and no understanding, then we're just gonna keep leveling out. And then then maybe AI will take over because we're stopping our intelligence to match theirs. That's when we get to be a problem. Because we know every single time we see prompts from AI and outputs and things like that, we know that we could do that better. But now, do you want to be better? That's a different question you have to ask yourself. Are you going to let AI take over your position? Because it will if you decide to match it. But I think if this is a community thing too, but then also it's a self thing. Like, are you going to just stop at the 5-minute video? Or are you going to realize that wasn't all that you needed to know? And you want to dive in and maybe watch that 15, maybe watch that hour-long video and see what you do. So I ask that for yourself. When people ask you questions, how do you approach them? Are you following any of these things? It could be subconsciously. This is no hate to anybody. It's ingrained. And then how confident are you asking questions? If you don't know something right now, because it's changing, everything's changing. I'm sure you were in a different talk before mine or will be in one, and you'll have something new to learn. So there's always going to be questions made, and we're all going to start at zero again at some point for something. So just remembering that for anybody, they're going to be at zero is going to be very important. So I just say keep that in the back of your brain. So in today, ever in life, just be somebody that doesn't let this continue. Puts a break in the process. Says, you know what, actually, I'm going to show you. Here's why you should care. Share your passion. You will have a passion for it, share it. And I promise that'll just make everything a whole lot better. That's all I have for you. Yes.
We have a few minutes for talks or for questions. If anyone has questions, raise your hand. We do have a live stream, so we'll want it on the mic.
Hi, well, first, thanks for the talk. That was awesome, especially the last couple of slides. That's something that I think we should keep to our heart, especially me, because I try to instruct people, so thanks a lot. When you said that when you were looking for information, there were a lot of like 5 minutes videos. Is it because you didn't find a lot of longer content, or the longer content was not like good enough somehow, or it was not surfaced by the algorithms and whatnot, or something else?
I want to say there was a combination of it, because when you don't know what's going on, you just kind of do what is, and then you kind of put the rest, and then so it was what first came up. So there's that. So there's just like the relevance and priority. So maybe those longer videos were in like the second or the third page, which again you already have to have some care to go that far beyond the third video. But then even when I did get there, I was noticing kind of those other things about. Even though they had my attention for an hour, it was still kind of trying to impress me for that long. So it was just the terminal. And I was like, I get it. And it worked. I got to what I needed to do, but it was interesting. So I would say there's a combination of both, and I think you have to like almost bridge them together to make what I think is suitable. Mind you, this is an opinion, but so that was kind of the reason for that.
Thanks.
Yes.
I know I don't normally get to ask questions, but you got to allow me today. Is it clear why, right? Because for some of us in this room, we've been doing this for a long time, and a lot of this feels like it's necessary because it's part of the job. But when I think about when I got started, it was never clear why people were doing what they were doing. After going through all of this, is it clear why you would want to do any of this?
Other question, why it's useful, like the product itself or any of these products are useful, or just why would anybody even think to recreate something like this or rebrand?
Yeah, like if you see someone working, you're like, why is this person digging this ditch? But if you see that it's raining and all the water is flowing through that ditch, you're like, I get why you would dig a ditch. But if I saw someone digging and you're like, why are you digging here? I am curious. Why are you doing this? And so a lot of the things that we do, the tools of the trade, it's not always clear why. I even talked to people that 10 years in, they say, I'm like, why are you doing that? I'm like, you know what? I don't know. I joined this company. They use VMware. I got VMware certified. And for the last 10 years, I've been creating VMs. But I don't know why. I need a job, I guess.
Yeah. I think I understand why what I learned is important. But I think that is different from the other why that you're asking. I still look to, even in the talks that I'm sitting in, I still look to ask, it's like, I wonder what their why is actually, because I can tell there's some people that might actually fall into that category of, it's hard out here, and is. But I don't know, I think there might gets to a point where does the why even matter? So I was like, I don't know if there's many people that are even asking why anymore. But I think for this, what I just did, I feel like I understand the why. But the more I get into it, I'll have to re-envision my own why for it, though, and that's still in progress.
Okay, so first I have to say I love the visual because as a learner, when I was first seeing things, I'm like, I have no idea what any of that stuff does or what it matters. Or then when I was learning, it's like learn Python the hard way, and I'm doing things with apples and oranges, and I'm like, I still don't understand. So I really love that visual and how you thought about that. I'll be using that too. I think one of the hard parts, obviously, is like hearing that the resources and different things for students aren't out there. I work at AWS. There's a number of offerings and different things that we have for student builders and different things. But do you have any good suggestions for like how we could work better to to make sure that those are visible? Right now, we're in a state of there's so much content and different places to find information. So trying to make sure that it's accessible and easy to find. And I know that's probably a loaded question, but if there's,
I just had a follow-up one. Is it, what is the content that you're trying to get out there?
Not necessarily content, it's access to resources. It's actually resources and using services without having to do, or having those charges, right? Like, I would look at that as a student and be like $74, $100, no thank you.
Yeah.
I've also heard horror stories of people building things, not turning it off, and $30,000 later.
Yes.
That's a big surprise. And so there are resources out there, but I just don't know that they're making them their ways to students. And so if there's any suggestions about how do we do that, I'd love to hear them.
I think, because it's definitely two-sided, but for you all, what comes when, because I'm thinking as a student, if I'm trying to reach out to something, it might that it's there, but then it kind of ties that back into, okay, is it pitched like this is why you should even take the time to use it? Because I know, like, for example, if it's a resource to explore, to, hey, here's this thing, here's these tokens, credits, whatever they call them, to play around with this thing. But it's like, how do you convince them that they have time to play around? I'm like, it's probably really cool, and it's probably bookmarked somewhere. But the environment they're in is like, unless it's going to write it or do it for you, it's not to explore. So I think it's one kind of having to, it sounds really weird, but convince them that this is even something they should take advantage of, because it being there is one thing, but convincing me that it's important will be the other. But then it also has to be within the climate that they're in, which you cannot control, or maybe you can, of allowing that time to just explore. For me, at least now, that does not exist. It literally doesn't. We're in class, they're literally telling us, because you will not have time, this part of the class will be AI. It's just like, okay. So it's kind of a give or take thing, but the way you pitch it, and then maybe even like showing the benefits of using this, and then how it could be, what it could produce for you, so then they can maybe make that dot connection where it's like, oh, I have to do this eventually. So maybe, okay, let me start. So maybe it feels like they're getting a head start. So making somebody feel like they're getting ahead with your thing rather than losing time is like, that's kind of how that would have to go. Yeah. Yes, sorry.
I believe you touched on a very important point in terms of tech isn't always beginner friendly. So my question for you, Ms. Hightower, is how did you navigate that in your experience? How were you able to punch through those barriers? Because I've believed in that for a long time, that we have that big disconnect between the people, those of us who've been in tech a long time, and I always say it's very valuable to have newcomers, because they can review our documentation, because we might remember all the workarounds to something, but it ain't in the docs. So, sorry, a little long, but how did you break through? And what worked for you?
You know what, actually, that kind of goes into how I picked my major. I was set that I was going to be a computer science major, and it was fine, I was. But I think I foresaw that for myself, is that I was going to get lost in it. And then I searched up, and I found other alternatives, and then I saw this thing called informatics here. And I was like, And I looked into it, and I found that it was all about making that connection. Or at least they claimed to, or it gave us the freedom to make that connection. So everything was open-ended and project-based, so that it gave us that space to connect the dots. So then, when I knew I had at least a backbone that I was going to be doing it towards it could just be a mini quarter-long project, but I cared about it. So it connected to something that I cared about, and I made sure I had to create that care. So then when I was in these, because I still had to take some CS classes separately, even though they weren't as connected, I took it as like, oh, I'm getting ahead, and it's something that I already care about, because that was laid for me. So I had to make it for myself. I had to really, really convince myself, like, is this something I want to do? And once I created that care, then I knew I was down to learn whatever it was. But that's not the same for a lot of people that I know. Some people are just like, I'm in it for the money, and then, which they might have some, a rude awakening. But anyways, they're here for the money, and you can tell they go into classes very differently than I do. It's hard. I don't want to do it. I don't understand, because they don't want to understand. They don't want to go in deep dive. It's like, yeah, it takes me 3 hours to study for a test. one test, and it's probably like 5 questions. And it's just different because I'm wanting to go down the rabbit hole. So that's kind of what that was.
First, I wanted to say that I really appreciated the point about the cron jobs, doing something unnecessary to learn. It's almost like you have to do something the hard way sometimes.
Yeah.
In order to see how simple it is, you know? Reference to Kubernetes the hard way. But my question is about AI. Is that making things easier? Because sometimes you could just prompt something and it'll do it for you. But I see that you learned the fundamentals and you map them out and you clearly you understand them. So did it make it easier for you to understand them, or did it kind of make you go somewhere else first before asking what are the fundamentals?
Because I've been playing around with AI for a while and my way of how I use it to support myself. So I knew that what it would give me was just going to be what it thought, and I did that on purpose. That it was probably not concrete, and that was fine. But then I also, because I knew for myself, I was like, okay, I made myself go on a different path. So of course it gave me links, and this is what you can do, and you'll get to these steps in 2 weeks. Like, it gave me my whole time frame, but I ignored that, just the front part. And then I purposely cut it off, did it the hard way for myself of just finding other people to recreate it. And then what I would do, though, is that after every time, like let's say I found a 15-minute video, it would probably take me about 45 minutes to get through it because I would stop. And then I would text with chat and be like, okay, I'm watching this, I'm understanding this, make my own connection, and then have it verify for me. And then I was like, okay. Because I could only feel really confident getting more information until I thought the one I had was solid. So that's what that was a lot of. So even in my drawing, I'm like, I have a base, and I could just ask question after question after question and go down so many rabbit holes. So that's what's helpful. But of course, I probably could have typed that first prompt in, and it would have spit it out for me. So I guess it's asking, is it helpful to produce the thing, or helpful for me to learn? So, yes.
Okay, so first off, your answering questions is even better than your great talk. So well done. You have so many talks ahead of you if you keep this up. As a platform engineer, I really appreciate Kelsey's question about why, but I'd really like to know, what would you rather do? And I could almost scope this for what would you rather do for the learning? What would you rather do for the implementation? Like, what would you rather? But I don't want to be that opinionated. What would you rather do?
I know I don't want to scope you down. What I'd rather do in...
You achieved an outcome, and that was phenomenal. And the hero's journey to get there was not trivial. If you had it to do over again, and the world was your oyster, and computers worked the way that you wished they did, what would you rather do instead to get that same outcome?
I think what I wish it was framed as was there's a problem. Like almost forcing me to believe that there is an issue. There is an issue, but make it very apparent, being like, holy crap, this is going to break on everybody else's computer just because it works on localhost. Like basically making like a case study was how it would have been dope, is having that there, and then it's your job to utilize resources and find tools to fix the problem. So not only is it like, I just like to win, so it could have been about anything. So it's like, okay, now you have that. My spark, my engagement, and then I can already see I need to care because it's broken, or whatever. It's not as where it could be. And then if I had that, then I'll be like, okay, then I would go and be like, okay, this is one thing that's broken, it's not scalable. Okay, now we look to see how can I make my application scalable. Oh, here are these things. I got, making it containers and using Kubernetes. Okay, I'm gonna learn how to do that so that I can fulfill the job and fill the things. So it's almost like rebranding. The outcome is not the goal. It's making it better seems like the bigger goal to make things. And then you're like forced to go down rabbit holes because you're guided in a way that puts you there. So that's what that would have been dope if there was like a case study for this on how to get to cloud native without giving it your own path. That would have been dope. Yes.
For the visuals, I enjoyed the visuals very much. I really loved them. I would love to take a longer peek at the whole thing at some point.
I plan on putting it there. Just like I said, it will be riddled with typos. So just no. But I plan on kind of making it into the thing.
But it's very amazing. And I'm a beginner when it comes to Kubernetes, Docker, and everything. I literally just installed Docker yesterday in one of the workshops. So I wanted to know if you have an analogy that you came up with yourself or that you learned. I know that I saw the little matchmaker and the traffic light man at the way bottom and everything, but would you say that you have an analogy that brings it all together in a whole, like I heard of a warehouse analogy once, but would you say that would be the best, or is there anything better that you can kind of come up with?
I know. When I was trying to do this, because I was trying to do the exact same thing, a lot of this was like for meals, meal prepping was for me, which was interesting. So, because I like, I had it up top as like the application is like, big dinner is what I want to recreate. And then I have it like broken down. It's like, okay, but I'm gonna meal prep my, my steak and my potatoes and my things separately, because they all have different body responsibilities. And then for this one was packaging them up like a lunchbox, so putting them in their actual containers for meal prep to put them in my fridge. And then I said Kubernetes was like, okay, well, maybe I made some of my meal prep a little bit too long, too late, some of it spoiled. And if I had a magical refrigerator, it would give me a new a new thing to meal prep, or at least let me know that it was time. Something was spoiling. It would let me know that something is running low. Like, you actually only have one container left. How many meal preps do you need to sustain yourself? Probably 4. Well, you only have 2. And then kind of things like that. And then, the rest of it being just like getting more information on a new recipe to make, having you share one with your friends and things like that. So, like I said, it's always going to be about food with me, I fear. But just that one was kind of interesting for me, because it's like it felt like something that actually makes sense to package up with some food, and then actually things can go wrong with them that made sense, spoiling and not having enough. So that was kind of the holistic one that I could think of. So.
I get 2 questions. That was a beautiful analogy, by the way. One thing I realized in that previous question that you had, in all of my teachings of this stuff, I never asked that question. How should it work? And I think some of my best work has always been challenging the tool and saying, she gave you this free reign. And I think a lot of us have Stockholm Syndrome. We don't even ask ourselves, is it okay for this to be way simpler than it is? Do we really need 90 of these pieces just to get an app to show up on your phone? And I think sometimes we feel like it's a rite of passage to say, yes, I did it the hard way, and you shall too. I even wrote a whole doc on how to do it the hard way. But I should have wrote a doc that said, how should it be?
Yes.
And I think that's where the creativity comes, because I don't think anyone would recreate this bicycle the way we built it if they had the opportunity to freely think about it before we inundate them with our past.
And then, I wish there was a job that was just that, because that's exactly what I thought. Even the whole time when I was learning, I was like, this is not how it would be. But because I didn't understand it yet, I didn't quite know if that was possible. But I sure did have a lot of notes apps of being like how it should be done. So, but yeah.
I don't know if you mentioned this before. What is the software you use for the notes?
Oh, this would be Freeform.
Freeform?
Yes. Shout out to Apple. They had that Freeform business there. Yes.
I think we got one more question.
That actually partially answered my question. I do not love using graphics software. I'm a musician, not an artist.
There you go.
So I was actually wondering how many drafts of this did you have to go through in order to have this graphic that is totally gorgeous, and I would have also paid money to use because I do not have the skill of making this. I would love to obtain it though, so that's why I'm wondering.
I got you. 0. This is the draft. Because, like I said, this is, if I had my notebook, my digital notebook out, you would see this has been my style for years. So I just go. The only type of draft is like, if I zoom way out, you might see some things that were like tossed. Like this was one way I thought I was gonna explain things, but then I was like, no, I feel like I'm just recopying what I've already seen, and that's not right. So it was about the what, but yeah, if I have the idea already, it went pretty quick. So no drafts, no erasing and restarting. I felt like I also didn't have time, to be honest with you. But I'm pretty comfortable with where it's at, and I think repetition, I'm a critiquer of myself to the day I die, so I know I have things I'd love to go in. I'm sure there's better ways to explain the way that I just explained it, but yeah.
Awesome. Well, wonderful talk. Thank you very much.
Thank you.
check, check. Check, 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 check.
Test, test. Test, 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 test. Test. Test, 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 test. Okay. Test, test, test. So All right, I see a few people rolling in, so we'll get started in just a couple of minutes. We should be able to make the time. Okay, I guess we'll get started. On any given day, I guess lunch will always be more important than platform strategy or platform engineering strategy. We get that. I guess people are still rolling in, but with the people that I have here, I guess let's start with raise your hands if you or your organization has a developer portal or a developer platform today. Okay, cool. And how about developers and how do they feel about that developer platform? Like, are they using it voluntarily? Is it there and remains to be utilized? Like, how would you say it is being utilized, or is it somewhat being utilized? Okay, cool. And for the others, probably platform is not a reality, and that's perfectly fine because that is actually a better answer anyways, right? Because it means that for those of us who haven't started that journey, the chance to do it right is what I'm essentially going to cover in this talk. My name is Faisal. I am a principal technical consultant at AHEAD. I lead our platform engineering and cloud practice. And I help customers with platform engineering strategy, architecture, and implementation. So today's agenda, platform engineering is kind of mainstream already, right? But still, there are quite a few components of platform engineering that battle with hype. So we're going to start the agenda with kind of understanding the hype, why platform engineering, why now, and we're going to kind of continue the journey. Essentially, we're going to go from what actually it is to how do you structure your team, how do you get return on investment, how do you prove that it's working, and how do you ensure that for those that you're building this platform, that they'll show up and they'll use it. One of the first things, which is considered an anti-pattern, that I hear often from customers is all about portals. Backstage, Harness, there are a lot of other options out there. And a lot of folks think that just standing up a portal is really what the platform is all about. And there's a lot there to unpack, but going back towards platform engineering as a discipline, the partner hype is pretty legit. Right? It has its own dedicated hype cycle. And when most teams hear platform engineering, going back to the first point, they're immediately thinking about a portal. in our customers, my customers are no different. And when you have that mindset, the adoption suffers because you're not really listening to and discussing why in the first place you're going to build a platform engineering discipline and provide platform as a product. Since I am part of platform engineering community as well as CNCF, I get to see some really compelling, great talks. Organizations that are doing work with platform engineering, standing up platform discipline, and involving the existing platform architecture. So obviously before 2021, there wasn't really much of a talk about platform con or platform engineering. Became relevant. Today, platform engineering has over 21,000 members. As I said before, Gartner Hype Cycle has platform engineering in its own space. And not to mention that platform engineering continues to get added on to other hype cycles, including container technologies, SRE, et cetera, et cetera. The forcing function for that is cloud entropy, right? Multiple cloud service providers, a lot of different technologies that are being used, CNCF landscape, that's, if you look at the landscape today versus 10 years ago, obviously, it's quite overwhelming, right? Another reason why platform engineering became a little bit more of a thing was there was this concept about DevOps, you build and you run it, right? Or if you build it from an engineering perspective, they'll come, right? So that reality did not happen. The DevOps reality with you build and you run it, right? And you kind of run into scaling issues there. So a lot of these things kind of led to where platform engineering is today and why it's so sought after. There's a Gartner Hype Cycle, and it's kind of in the peak of inflation. But when we get started, especially when I talk to customers about platform engineering, there's always this a little bit of a challenge making it clear what platform engineering is and what it is not, right? And oftentimes it starts with an IDP, a platform versus portal, right? The conversation always starts with a portal rather than a platform. And when you're talking to customers, giving them the understanding that exposing those APIs, documentation, all those things are more relevant, right? It's almost like building a house, and you start with the door, and door being the portal, right? And if you don't have the foundation for the platform, then it all kind of collapses. So oftentimes, it's all about like platform versus portal, and the discipline of platform engineering essentially is about designing and building tool chains and workflows that enable self-service, right? That's the North Star. That's the goal to ensure that you get out of the ways of developers, right? And oftentimes it's a business-led conversation, at least for me, where when I get pulled in, it's like, we can go to market faster. We have a lot of challenges. It takes us 3 weeks to build an environment. There's a lot of friction, so on and so forth, right? From a platform perspective, it's essentially a self-service layer of APIs, tools, services that the platform provides. And it's interesting that oftentimes when I walk in, it's an engineering-led conversation and not a developer. And they're like, oh, we need a platform. It's like, okay, great. What have you heard from your developer community? Well, we haven't really quite started that conversation, right? And I think you're kind of already behind the curve if you start your platform engineering discipline and you don't have those conversations with your dev peers. So anyways, so these are some of the things that I hear. And just kind of looking at the IDP or the platform and the various different planes, the landscape continues to mature. This is from platform engineering community, all the various planes, including observability, developer control plane. And so as you can see, just like a CNCF landscape, this thing is evolving as well. And it's quite quite an undertaking, right? So in order for you to get to this level of maturity, you need to understand and embrace the complexity that a platform will bring to you, right? These are just 5 planes, and the point is essentially is to not build all of them together, right, at one time, but to start where the biggest challenge is for your organization, right? And then in building towards, you know, your early decision, you know, instead of buying something out of the box and just implementing it. When I talk to customers, especially around platform engineering initiatives, this is how I kind of start, again, borrowed from the platform engineering community. If you look at the top end, the business, all they care about is the value, right? Why should we invest in a platform? Is it going to reduce the cost eventually? The answer, obviously, just so you know, is no, at least to start out of the gate, right? There's investment to be made, training to be done, getting people upskilled. So that investment of technology and people is kind of, you know, quite an undertaking, right? So those are some of the challenges from a business management perspective. And essentially, that's all they care about, business impact, right? So they don't care about a portal. They don't care about Backstage. They don't care about whether you're going to use Terraform or Pulumi or Crossplane for managing control planes, right? And from the value drivers perspective, right, the value that a platform provides is through the personas of infrastructure engineers, platform engineers, DevX engineers. Essentially, these are the people who are going to help you standardize and automate a lot of those functionalities that are today just kind of click ops or just taking forever. Maybe you have infrastructure as code, but there's no CI/CD aspect to it. And then obviously the pains to the bottom, right, where, you know, these are things that if you work in IT, you kind of live through these, right, on a daily basis, which is slow, missing services, ticket ops, click ops, cognitive load, so on and so forth. So again, you know, the pains are pretty self-evident, right? Slow self-service, manual review processes, cognitive load, insecure configs, and the value drivers from a business perspective are how do you make sure that we get the value through standardization, right? Ability to move faster, get products out into the market. And as I said before, you know, the biggest anti-pattern that we see is people starting with portal. Somebody has a portal installed, running. They're like, this is it, solution right here. Let's start here. And as I said before, you know, you're building a door without building, you know, the foundation layers, the CI/CD, the automation pieces, exposing those APIs, documentation. And if you don't do that, portal, if you put it out there, will just expose all those challenges, right? One way to kind of start a conversation at an organization for me is to leverage what we call a platform maturity assessment. And essentially, it's across people, processes, obviously, but understanding the investment, the adoption, the interfaces, the operations, and how do you measure it, right? All of these, and what we find is organizations that lack that platform capability and maturity, they're kind of around the provisional and somewhat operational stage. And so that's, you know, this is, you know, using this as a diagnostic tool and not a report card actually is probably the best start if you and your organization are kind of embarking on this journey. You want to create that safe space, understand the inadequacies and challenges, lack of investment, right? Maybe leadership doesn't buy in, maybe quite does not understand. So these are some of the challenges that you could address through a platform maturity assessment framework like this one. And then the next thing that I get into it, if it's not the tool, if it's not portal, it's all about, well, that's cool, let's do platform engineering. And what do I need to do to be a platform engineer, right? And and you obviously can grow some of those existing personas in your organization, right? So if you have a DevOps engineer, they could potentially fill the role of a DevX engineer, right? Because it's all about understanding the developer pain point and those frictions. But going back to Conway's law, right? If you're going to design a system based on existing structure of the organization and the patterns and the people and those behaviors, you're going to get the same system all over again. You're not going to solve. You've got the DevX persona. These are the ones that are bridging the gap between the devs and platform engineers. And what I have seen at least is the best personas, if you already have an existing DevOps mindset or a few personas that address that, they are the ones that can address the gap and take the ownership of being a DevOps platform engineer. These are the guys that are kind of, taking ownership of the golden paths, feedback loops, adoption. And then as you start to mature, let's say you go beyond a version or two, and you're evolving, this is when you want to make sure that you have a dedicated platform product manager, right? They're the ones that own the roadmap, the life cycle. Between this and the DevX persona, I think these two are really important, relevant, because the DevX persona ensures that it becomes an organic movement. So when a DevX engineer solves a problem and the dev team sees the value, your platform kind of starts to take on more and more workload, because your platform does not need any more intros. People will talk about your platform. One dev team that saw friction being removed, their cognitive load being reduced, will talk to another team. And that's how platform take over, right? And become a thing. The product manager, their job is to help understand the risks and challenges and how to align with the business goals and show the value to the business to say, look, maybe 4 months ago, when a new developer would join, it would take them 3 weeks, 4 weeks to do their first pull request. Today, as a byproduct of this effort, we've reduced that time, right? Yesterday, it used to take 2 weeks to build an environment, and today it takes, maybe 2 days or less. So these two, the bottom left personas, seem to really help the platform evolve and grow. Common theme, anti-patterns, poor documentation, undefined APIs, right? Developers lose confidence. And so these are not edge cases, right? Like these are all every one of these patterns show up in almost all platform engineering engagements. So, and usually within the first 6 months, right? So trying to build a platform, but you still don't, have those documentations and undefined APIs. Team collaboration, it starts out really, in a very exciting manner. And then, you're enabling, team spins up short-term partnerships, but they're not growing, right? Or they are just so elongated that, they're just over-functioning with enabling team, right? So app teams never build that independence that is needed. So that's on the other side of the spectrum. How do you make that business case, right? For me as a consultant, when I'm working with an organization, it's all about showing the return on investment. So I can talk, and by the way, I used to work at HashiCorp, so I can talk technology, right? And that's great, but that's not what many of my customers care, especially the stakeholders that are bringing me in. They don't care about technology. They don't care about what your upstream infrastructure as code looks like, or whether you're going to use Flux or Argo downstream. For them, it's all about, do a due diligence upfront. Tell me what those challenges are, the friction is. What is that impact to my business? What is that cost? And then show me the value. And that's important because for a peer at a technical level who's leveraging a platform, they need to show value, right? So if you start with some sort of a from the previous slide as well, it'll probably come up in the next slide. The reality is that you want to show the value, right? And if you can show your baseline and then you start to show improvement across productivity, delivery, improving, right? Resiliency, tooling consolidation, right? You're saving cost. You bring in a new tool into architecture review board and say you want to use this, but then you retire another tool, right? So you're minimizing that tech debt. And how do you improve the talent retention? So these are some of the ways that you can show value with your platform. And by the way, business does not understand Dora Matrix. So I've walked in with engineers to make a case to the business, and the engineers and developers are talking about Dora and Space Matrix. They're good, right? They're good, but you need to show value, right, through numbers. And so this is perhaps one way to do that. Certainly there are other approaches with ROI that where you can get more elaborated. We're doing measurement, a quantitative measurement, but this is just one example. And as I said, Dora Matrix are important, but they're lagging indicators, right? And so Dora tells you what happened, right? But DevX Matrix, for example, will tell you why it happened. And that's important, right? Because you need both to help address and run that platform as a product. So if your platform is healthy, right, what happens? Support ticket volume goes down, right? Adoption goes up. You don't have to talk about your platform anymore. Your dev peers are talking among each other, right? And these two signals usually are the leading indicators that I've seen, where adoption goes up, ticket ops goes down, people are talking about it, and while you're building the capabilities of your product as well, right, through the course of this. And another way to do that is developer net promoter score, right? So what that really means is how likely is a developer to recommend, as I said, your tool to other dev peers. So how do you start on this journey, right? And oftentimes you hear an MVP approach with pretty much every initiative that you start. In platform world, there's another way to look at it, which is thinnest viable platform. If we looked at this, this reference architecture, right? So you're not going to be able to cover everything on day one. Obviously, you won't be able to, right? So you got to pick what is that thinnest viable product in your platform, right? You can still have a vision of where you want to go eventually, but you want to start with, maybe pick the integration and delivery plane, right? That's where maybe the most focus should be. Then maybe ensure that, it's done with security, add observability, improve that, and then you continue on, and eventually you bring in a portal into the mix. So defining and then assessing, right? So how do identifying what is the intent, right? What is the intent for this platform? What are those dev pain points that you're trying to solve? What is the current state? We talked about the maturity assessment, current state assessment, understanding across those 5 maturity assessments, right? Dimensions. And then mapping that team structure. So you can have a definition of what the platform is, but do you have the talent? Do you have the team that you can stand up to help support? Then obviously building it and making sure that you are able to connect with your customers, right, through that DevX persona, right, that DevX platform engineer. So you're constantly getting that feedback loop as you're evolving. So 4 to 6 weeks, usually on the average, you want to start building features. You want to go back and forth. You want to understand how your platform is working. You want to start collecting data, right, from an initial developer survey, and then follow up and say, what have we addressed so far, right? And prioritize those, right? I mean, We talk about golden paths, right? They're off paths, right? Off-road paths, maybe, if you want to call them. Not a good place, right? Early on, you want to start with those rinse and repeatable patterns where, 60, 70, 80% of the use cases can be addressed through that golden path. If you do that, that shows momentum. And then measuring and evangelizing, right? I showed you one example, but as long as you take a good baseline metric, right, you should be able to show value. And to track adoption, right? Business wants to know how you are making your solution more mainstream. How many more people are using it? Those who are using it, how do they value your system? What is the score that they're providing? Not just DORA matrix, right? And then scaling and sustaining, right? So once you get on that trajectory where the platform starts to do what it's supposed to do, it helps reduce that cognitive load. The developer productivity starts to grow. Then what you're going to find is a sort of like a cloud-native platform engineering center of enablement where people are willing to talk to you, come in during your office hours, share with you where they want to take the product next. And usually this is led by a platform product and the platform engineering lead. And essentially treating platform as a product, right? Because if you have a roadmap, you got backlog, and SLAs, it is essentially now a product. So key takeaways, strategy over tooling for sure, right? Have a conversation, understand what it's all about, because if you just go in with a tool that nobody understands, nobody sees the value, or it doesn't address the challenges and risks that already are there, you can have a tool, it's just going to fall flat, right? And treat platform engineering as a discipline. It is a combination of products, obviously across those planes that we talked about, but start with that one problem that you can address. Your team structure is your architecture, right? I mean, and we talked about Conway's Law. This is your chance to address the shortcoming of your system, the people, the processes, right? With empathy, of course, to say this is not working, right? Like, we need this type of talent to help address the gap. We need to change the way we do things, right? I was working with one team, one customer, and they were like, well, we've got a repo. We've got a front-end form. Developers can go and clone and have at it. So I connected with the developers next. I was like, well, what seems to be the problem? You have a repo. You can stand up infrastructure. They're like, yeah, but what about configuration parameters? Like, we don't know how to build an environment. Like, the repo is there, but what we need to work with, in other words, create tickets to go back and work with the infrastructure team to update the repo before we can even run it, right? So maybe in the right step, in the right direction, but quite not a platform, right? Treating platform like a product, measuring what matters, right? DORA is a starting point, but you do need to understand by continuously engaging with developers to understand that how you're improving on those DevX signals. And then providing that ROI back to the business as well, not just saying, great job, developers seem to be happy. And don't try to do everything, obviously, at once. That TVP or the thinnest viable platform always win. One small piece, you start building momentum, you show the value, your dev peers will be your biggest champion. And that's pretty much it. I wanted to purposely leave some time for conversation, especially if you have your own thoughts or any questions that I can answer. And by the way, I don't have a proctor here or anybody to support, so I'm happy to just take the questions without a mic. Sure. I'm sorry, can you repeat that again? It depends. right? I mean, for me, I think if I get the question right, is who's the audience for the platform, right? Yeah. Yes. 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 And that is your primary customer.
And so if an enterprise installs software, primarily they buy software and install it, commercial off the shelf.
Sure. Well, it depends, right? I mean, if you are installing software that's running on top of, let's say, middleware, right? Or you're installing software that's still running on traditional or cloud infrastructure, you still have a need to put together infrastructure, right? And so unless until you have a very dev-oriented system in place, and there are organizations out there that democratize the infrastructure to the dev teams. And so then the dev teams are just building, and they're smaller teams, let's say 25 to 30 size dev teams, then platform does not make sense, or platform engineering system does not make sense.
Because you said one engineer for every 20 devs.
Yes.
So that means you must have at least more than 20 devs before you...
Yes, that's a good point. What I have seen is customers with, especially if your size, if your dev size is around 50 or below, chances are you're probably not starting on a platform engineering journey. So on the average, customers that I work with have anywhere from 500 to 1,500 developers in-house, right?
So you described how platform engineering works, but by experience and personal knowledge, no one is using it completely in the companies. As far as I have experience, I think you will share or negate this. Do you think that developers portal, CI/CD, and all of those practices will be... Yeah, I can repeat the question. So basically for me, platform engineering in these days is known, it was well described, but we have a problem because no one is using it. So in example, when you do a pull request in a company or a release process, no one is following the automation, but everyone is putting gates, like signatures, check off, people that are having a review, peer review, or similar. While in platform engineering, this should be all automated by workflows, by an example in Kubernetes using Argo CD, or checkpoints that are automated. There are other cases for platform engineering, like in example, the pipelines and the controls of software billing of material, everything related to container image and similar. So a lot of principles that you described. And finally, developer portals. They are very, very useful, but no one is using it as far as I see. There are a lot of offers commercially. Why do you think this is so hard for people? This is the question. Why?
So yeah, the question is why is platform engineering and the leveraging or utilization of portals is so difficult, right? Because it's not a traditional persona of an engineer, right? It does require a lot of stitching, right? When you think about the golden path, it is a lot of stitching together, right? Having that understanding of the developer workflows, right? So it requires a community of peers to work together to make it sticky, to make it work. And so if, as I said before, if it's led by infrastructure engineering, it's just not going to work because your portal is going to expose only the reality that you have underneath the system, right? If you don't have those strengthened CI/CD pipelines, if you have not exposed to the APIs and documentation, your portal is not going to be able to do the job that it was meant to do. So having that understanding, working collaboratively with your teams, with your other, cross-functional teams is the only way to make a platform successful, and then kind of building collaboratively. Yes.
So a challenge that we've run into is, we have, a lot of this stuff in place, and, there's templates, the golden paths, and so on. Teams take those, they get, all those templates and stuff end up in the repo, they're using it, everything's fine, and then something changes, right? Either, we make a change to what that should look like, or, some external factors change that requires updates. And now we've got, 1,000 instances of the old pattern. How do you get everyone to go get the new pattern? That's something we've struggled with, and wanted to know if you had any thoughts around that kind of thing.
So I guess my first question would be, how involved are the platform engineering DevX personas with the developers? Because if there is a disconnect, because they should be addressing the golden paths, they should be the ones building the golden paths or improving on those that are needed. So how sticky is that relationship between the developer experience engineers and the developers?
So some teams need, more help than others. Some teams are fairly up to date on the technology. They can pretty much, okay, give me some docs, give me some templates, and I can run with it. Others are coming from a on-prem environment where they're just not used to any of that, needing a lot more help. So it varies quite a bit depending on team. But I guess my point is, the path was established and it was fine at the time, and then something changed for whatever reason. How do you get all the existing stuff to adopt that change?
Shouldn't that be the job of a developer experience persona? I mean, they are the ones that are the gatekeepers. They're the ones that are working with the dev personas, right, in support of building those golden paths, right, whether they are the existing ones or the new ones, or updating the ones that are already in place. Wouldn't that be the job of that one-to-one personas? That's the way I think about that. Like, I mean, what you're saying is the golden paths are built, more are built, then the ones that are built are no longer applicable, right? Or they're deviating from what's really needed.
Trivial example, external secrets operator updated their API version from V1 beta 1 to V1.
Yeah.
There's out in dozens and hundreds of repos, there's thousands of instances of that one little change that needs to be made everywhere.
Yeah.
They're all owned by different teams, certainly so on the platform side, we're going to making that change requires them to make an update on their side, and everything's going to be crashing down horribly if they don't.
Yeah.
But we don't own their code. We don't, right? So it's just.
What is the platform engineering setup today? Like, what makes up a platform engineering team? Is this strictly around the infrastructure and that's it, or like, tell me more about your current setup?
So my area of responsibility is the Kubernetes clusters that
Okay.
this stuff runs on, but there are, there's a broader.
So you create a cluster, you expose the namespaces, and then you go away, right? And then.
Well, so there's a broader team that handles the other aspects.
Sure.
Right? So we have a portal and all the templates that go into it, and a bunch of other layers. But ultimately, the app team gets a point in time copy of whatever the latest and greatest is when they start. But fast forward a year, and some things have changed and requires updates on their end. We can update the templates.
Yeah.
But, their copy was a point in time from before that change. So pushing those updates to all the app teams has been problematic.
I think so. That is, then there should be a dedicated persona that works with the developer team to kind of address those things. That's the only way that I can think of. Like having a core platform engineering. I talked about those 4 personas, right? So I keep going back to the DevX persona because I just feel that they have replaced the DevOps of the yesteryears. They're the ones that understand what the friction points are. They are also the ones who should be in the better position to understand how to improve the challenges that you're talking about. That's how I think about it. But let me think about that. Maybe I can connect with you afterwards and kind of understand a little bit better and get you a better answer. Cool. Awesome. Any other questions? Cool. Awesome. Thank you very much.
Check, check. Check, check.
Okay, yeah. It says this, but it also says low. I don't know what low
Oh,
is.
this was the root. Yeah, it's just said that the whole time. But as long as the battery is
Cool. Great. So I just flick this on when I'm ready to speak.
Yep.
Sounds great, friends. Thank you. Yeah. I think my mic is live now. Okay, cool. I should probably pull up my slides. Here we go.
All right, I guess we'll get started. So I get the pleasure of introducing Lee Capelli. For those who have not had a chance to hear Lee speak before, he's an exciting speaker, just so you guys know. So you guys are in for a treat. Lee is a Kubernetes contributor. He's a cloud native practitioner and one of the most entertaining speakers, at least in my opinion. We'll see today how it goes. But yeah, what makes Lee stands out is that isn't just his depth of his technical knowledge. It's also that he actually makes stuff fun to watch. So with, I guess, no further delay, Lee?
Yeah, thank you, Facel. Yeah. Hey, everyone. Excited to be back from lunch a little bit. Actually had a friend run and get me something, which was a pretty fun surprise. But today, I have a little bit less of a theatrical presentation than typical, just slightly. And we're talking about tracing what a GitOps reconcile looks like in the cluster, and in your repos, and in the storage layer beyond Kubernetes a little bit. And then I'm going to be using Flux as an example because that's what I know best. I've been on the Flux project now for the better part of a decade, and we are coming up almost on our 10-year anniversary this year. So if anyone, Flux users in the audience? Sweet. Nice, Fab. Great. So what actually happens between a git commit and running pods is something we're going to get into. Just a little bit about me. Again, yeah, I'm a Flux core maintainer. I work with Control Plane, which is a company that kind of came in the wake of Weaveworks and saw some huge value in the project. Flux, runs pretty much in every cell tower in the nation, and on planes and satellites and tractors that are picking apples and point of sale systems everywhere. So it's all over the place, and that means that you really do need a secure footprint and approach. And that's a Control Plane specialty. We, helped do a security audit of GCE and helping the Google Cloud team, as well as the basis for GKE, and work with space agencies and financial services and all kinds of people. And those are some of the clusters that I have the immense and humbling privilege of working on. And when I stand at the Flux booth, I talk with people who are using Flux in all sorts of wild ways. So feel free to tell me what weird thing you're doing with Flux or other weird stuff like Nix. I grew up here in LA, so it's always nice to come back to SCaLE. And then I have a couple of side quests that I'm interested in, and Jerome actually helped me with one of those today, so he grabbed me a boba. Thank you, Jerome. And if anyone plays Dance Rush or Pump It Up or Dance Dance Revolution or wants to do anything on a skateboard, then those are my side quests. Cool. And just a little quick note on why GitOps. GitOps, I think, is more than just a technical solution. Whenever we think about GitOps in an organization, we're solving a people problem. And it's funny, working in open source for so long, we're always solving all kinds of strange people problems. But GitOps brings the interface of our fancy distributed computers with all sorts of computer science necessary in promise theory to realize our desired state, to what we want happening across the globe. It brings that interface to a place where we can actually collaborate on it with each other. And that's why GitOps is so important. And GitOps is really an evolution of many of the problems that we ran into in the DevOps era when we first started formalizing what it really means to work with each other in these contracts and realize that there's all kinds of ways to deal with and name and identify and pattern organizational dysfunction and how we can decide what we owe to each other. But ain't nobody logging into your Kubernetes cluster to talk to your teammates, right? You're always doing that somewhere else. And so we've got this staging area to work together and keep a central record of how the intellectual property of our businesses and our projects evolve. Flux helps you do that. More succinctly, write funny YAML of deployment, git commit, am, YOLO, git push, and then the pods all over the world just go. But I wish I could roll my R's better because I would really indulge in rolling that out. So Flux has a couple of controllers. I wrote this little mermaid diagram. We have a better version of this on the Flux website. There's the source controller in Flux, which fetches artifacts. And that's more than just Git. One of the really cool things that's happening with our customers and with sophisticated Flux users is we've realized, gosh, there's already a really good immutable state store that is tightly coupled to the lifecycle and availability of every single distributed computer that you're running with Kubernetes. You need an OCI repository. And whether or not you're using that because you buy it from AWS or you're running your own Harbor instance or doing some weird thing on NFS thing exposed from your Gluster storage, then you've got an OCI repo and you're probably happy with how available it is and your cluster has the ability to authenticate it to it already. So if you put sources there, the actual things that you want to run on your cluster, the desired state, into the OCI repo, source controller can fetch it, whether it's from Git or OCI, pull it in, serve it on a private network policy protected HTTP server, and then customized controller and Helm controller can go and realize those things into the Kubernetes API. Yay, now you've got pods running, right? Now, what if things happen? Well, we've got our notification controller that's ready to start using your desired alert configurations to ping you on Slack or Discord or update some git commit status notification. This is kind of the core of Flux, and these are the controllers that you get by default. But then if you move over to the image reflector controller and the image automation controller, we can also start to close the loop, right? So when we push stuff to Git, we are asking the computer to change the desired state of the world. But what if we maybe push stuff somewhere else, like say push some tags for an application image to an image registry? Well, there's more sources than just the YAML files that we want to run in the cluster. Say we update a version of an artifact that we want to deploy. Say we update a version of an artifact of an OCI repo that we want to deploy the manifests of. Well, the image reflector controller can watch those tag updates, and it can follow your image automation policies in order to push commits back to Git and maybe even build those things back into OCI repos to then flush through and then do more deployment. And so now you have an automated loop for machines to actually start operating and collaborating with you in your place of collaboration. And this is something that's really difficult to do in a way where you keep a record of what the heck happened and what the intent was and how environments pushed from one to another, and that sort of thing inside of a Kubernetes cluster. But when you do it in Git and you do it with GitOps, you start to build a really cool basis for things working together. So that's the Flux controller architecture a little bit. Now there's a Bootstrap problem here. How the heck does Flux even get into the cluster and start talking to Git? You need to set up your repo. You got to configure some access. You're logging into GitHub, and you're like, where's the deploy key thing? Let me go and make sure that this thing has read access, and then I got to install Flux onto not just one, but 10 clusters, and then configure Flux with the proper secrets, and each one has to have a secret because, those things shouldn't have the ability to read the state of another cluster, and then we've got to also manage Flux itself somehow, so maybe we can do that from the Git repo. And so we wrote a little command to do this back in the early Flux days when we rewrote Flux 2, which I think was in 2020, 2019, something like that. And with Flux Bootstrap, you can just be like, hey, I have this GitHub org, here's this repo. And then it's going to go and make sure that the repo exists. If it's not there already, make sure using your personal access token to generate a P pair, put the thing there, commit the manifest to the repo, apply the components to the cluster, make sure that the SSH key is configured there. You know, like it just all does it for you in one command. And that was nice. But then we wrote Flux operator because people were like, man, I really got to run this CLI like a bunch of times and update 100 repos for my fleet of 1,000 clusters. And so you can just run Flux operator there, put a Flux instance in there. And instead of having to commit the Flux manifest, which you're really just getting from us, the upstream project, maybe with your patches, you can specify an OCI distribution of Flux from an OCI repository with a manifest. It's signed with salsa build level 3 build provenance. You can verify that key. Flux operator will do it by default. Decide which components you want to deploy, put some patches on, and sync it up to your repo. And here, you can actually do completely Gitless GitOps. And just point Flux to manifests that are straight from OCI. So your Bootstrap doesn't even have to involve any secrets and any availability or dependency on Git, even from the very root of your cluster, which is quite nice if you're using a managed Kubernetes provider. You can do passwordless machine identity, and everything will just Bootstrap. There's no secrets at all. So that's pretty cool. Check out Flux operator at fluxoperator.dev. We're just trying to make things a little bit simpler. This is a control plane Flux CD project, not just a Flux upstream project. The license is a little bit different, but it is fully open source and free to use and everything like that. We've got a nice user interface. I'll show you that in a sec. But, okay. So in order to build Flux, right, this talk is about an anatomy of what it takes to reconcile resources into the cluster safely, securely, and in a performant manner, which are the 3 tenets of the Flux project, the things that guide us, and the things that's like our North Star for the past decade. Fast, performant, right, secure, and extensible, and trustworthy. And so we use the core Kubernetes SDKs to build Flux, and we do it in the style of Kubernetes. There's client Go, there's API machinery, controller runtime, which has gotten significantly more reliable and fun to use over the years, but was definitely a battle in the early days. And then things like the customized API and KYAML from the Kubernetes project to build YAML, and then also post-render stuff for Helm. There's a couple of core libraries. So we've got this repo called pkg in the Flux directory, in the Flux org. You'll see this like in Go projects, and a bunch of people really dislike it, but it works well for us. We'll put like runtime or SSA or a bunch of SOPs logic for decrypting secrets, or dealing with SSH keys and like knowing which file names to read them from inside of a secret and how to unpack a secret. Things that are used all over the Flux project, we tend to create a folder for it and a package in package. And then I can't talk about like the core of Flux without at least mentioning GoGit, which is a highly extensible Git implementation in pure Go. So when we built Flux, we really wanted to avoid it just being a pile of bash scripts. And we're very proud to say that pretty much all of Flux is native Go SDKs, which means that it can run in soft multi-tenancy with things concurrently, passing around contexts and clients that only have permissions to the things that they have. We don't pollute the environment variables overly. We're not polluting the file system. Like, we're just creating structs and calling methods in relatively type-safe and sane Go. And that's super cool. Because that means that we can clone a bunch of Git repos concurrently and put them on the file system and make sure that only the people who have access to them, you know, in the namespaces that they need to be. It just respects the security model of Kubernetes itself. So that's what Source Controller uses to go and get your Git repos. We also use the Helm SDK natively, right? So there's no executing the Helm binary. There's the Helm v3 and v4 packages. Flux now supports Helm v4 by default. We have an API version tracker in the status of all of your existing Helm releases, so that if your cluster has thousands of Helm releases that are already using v3 APIs, we're not automatically changing behavior on you. But if you're creating new Helm releases with Flux 2.8, Everything is going to be Helm 4, which is brand new. And a massive, massive effort went into this from Stefan and from Matthias for the Flux 2.8 release. So huge thanks to them for creating a very high quality, very safe implementation of Helm 4. And also kudos to the Helm 4 people for working with us in upstream to actually fix bugs that we found. And getting them out in a really rapid release cycle. But the reason that it's fun that we use the Helm SDK is we can actually implement features that are impossible to do with the Helm CLI. So we implemented our own drift detection using some of the knowledge and comparison logic that we learned in customized controller over the years. So we implemented that. You can also do Helm's storage in a separate namespace, which makes sure that your application doesn't have access to modify the manifests that are necessary to deploy itself. And that means that if you've got secret read, like say as a developer in your app namespace, you don't necessarily have the ability to go and muck with everything that's managing your app. Prevents the security boundary from being escalated there. There's fine-grained status reporting, and you can react on that, right? So when a Helm release is running some tests, you have an API that's telling you that that's happening exactly. It's not just some random log message inside of a terminal. In the same way, like this test failed, or this test succeeded, or we're doing a Helm rollback, or these things are healthy and this thing is not, or these are the resources that got deployed with your Helm release. When you have the Helm SDK and you're representing everything as a structured state machine, you get to do that. You get to do complex lifecycle and remediation. This is a new feature that we have. It's health check context cancel. When you say run a Helm upgrade with the Helm CLI, and you just say, okay, I hope this succeeds in 15 minutes, but you don't know what's going to happen, and then you pass it the rollback flag and all of these other things to make your CI safe when you're using a GitOps action for it. And then you want to, I don't know, realize that you had a typo, and you want to redeploy. So are you going to wait 15 minutes for that thing to time out? Or are you just going to brutally kill the Helm CLI with the entire lifecycle of the GitOps action? This is something that there's no answer for in the Helm CLI because it's an imperative tool with a global background context. But I will show you a PR later that solves that problem. And yeah, you just get more efficient client machinery. Also, just we need to talk to all of the cloud providers to integrate with their key management and their identity. Again, all the machine identity stuff that we released last year, as well as working with container registries. So there's the Google Go container registry package and the ORAS package. Cosign, SOPs for decrypting secrets, notation as well for verifying signatures, cosign verifying signatures. File path, secure join, that's a fun one as well. And we use controller runtime with a bunch of managers, cache setup, clients, rate limiters, et cetera, and we encode our opinions inside of the package library. I already talked about why we don't want to be execing a bunch of binaries, so we'll just skip this slide. But it's more secure that way and better and faster. So let's go and look at a little bit of code because I feel like doing a lot of rambling. So I'm going to hop over to the main Go for customized controller, just kind of showing. Normally, when I work on Flux, I have this little kind of directory where I just put a bunch of stuff. This is roughly the repos that I work on at any one point, and then some experiments and stuff. And so in the main for customized controller, we need to set up a manager. Now, this is a binary that takes in a bunch of command line flags, options, and feature gates, and things like that, so we have to set that up, right? So here, for instance, there's disallowed field managers with a, you can or if you want a global SOPs age decryption secret, you can set it here. And then we take some feature gates, pull them in. You can, have to plumb all of the fields that you just took in. And then we try to get a configuration from controller runtime. We want to make that config. And here we're starting to deal with details around leader election if you're running more than one customized controller for high availability. Working on all of this, plumbing the settings from the command line flags through. Then we make a manager. We've got a bunch of error handling. You've got I just added this factory in here. And then eventually you get to instantiating this, which is where we get to the meat of the logic of customized controller. Right? So we're passing all of these options to this reconciler object, and then we set up that reconciler with the manager, and then start it. So this customized reconciler is part of the style of implementing a controller with controller runtime. So if I go to this reconciler, there will be a reconcile func. And this reconcile func is what happens anytime there is a request to operate on a new resource inside of the Kubernetes cluster, which this is registered for the customizations API. So anytime we change a customization inside of the Kube API, we'll get the reconcile func, right? And we come down, and the very first thing we need to do when we, aside from setting up finalizers, again, there's like a lot of machinery here to make it happen. The first thing that we'll need to do is get a source, right? So customized controller will go and grab a source tarball from source controller, right? And it'll make sure that that is compliant with the artifact API. The next thing that we'll need to do is check our dependencies. Customized controller can create a directed acyclical graph with a bunch of other customizations and order them to make sure that, say, you don't install a controller before its CRDs are present in the cluster, or that you don't try to configure cert manager before it's able to actually do that. And this sort of ordering thing is another thing that's difficult to do without GitOps. And then we kind of get in, and if we look for the apply kind of phase, you'll see that there's this idea of change sets. And in order for us to promise you that your desired state is going to be reached, a big difference between using a Flux customization and doing a kubectl apply is that when you kubectl apply, it kind of just tries to go file name by file name and resource by resource, and it sprays them into the cluster best effort. What we do with Flux is we do a server-side apply, and before we actually run the server-side apply, we create a change set, we track what we expect to see, we do the server-side apply as a dry run, and we compare that with this concept of an inventory. So we make an inventory, and we are going to put that inventory into the status of the customization. So the inventory is going to track every name, every namespace, every group, version, and kind of the thing that you are expecting in the desired state for the source of this customization, if it's a folder at a particular branch in your repo or something. And if our dry run succeeds, then we have reasonable expectation that when we actually try the server-side apply, bar a couple of edge cases, that we are going to succeed. And then kind of under the hood, actually, in the PKG SSA library, we do this in phases for like certain exceptions, like in RBAC, where you always want a cluster role to be applied first, and that sort of thing. But we'll always dry run it, and then run the stages, and then try to get that change set to be atomic. And what this prevents you from happening is, say, you update 4 or 5 files in your repo, and one of them has a typo, but the other 4 are good, and you accidentally apply only 2 of them and then reach a stuck state. So we're really trying to avoid you having a non-atomic behavior, right? If there's a typo, if there's an invalid API declaration inside of one thing in the change set, we are going to use this inventory tracking behavior to prevent that from making it into the cluster. And then we also use that inventory to do drift detection. That's what this diff is using. And that's also how we prune. So this is a little bit of the guts of customized controller. That's kind of the rough logic and how we set up the manager. And we'll kind of pop back out. So you can see it's already complicated enough to deal with applying a couple of resources to Kubernetes. Right? And that's just in customized controller, which is all code that we mostly control. And so it's really nice that we've got controller runtime to deal with our work queue, deal with storage, deal with the kind of inventory of everything. And we've got how we use API machinery. Again, just as a recap, server-side apply is it came around kind of in like around 2018, and Flux was one of the earliest kind of users of it at scale. You know, from the Kubernetes client side, we found a lot of bugs over the years, and it's now in a really nice place. This gives us our conflict resolution and field ownership, and gets away from all of the weird annotation stuff that needed to happen in order for kubectl to manage this problem before. Now, this is a really cool code snippet, also from Customized Controller. And I made a slide for this specifically because it's something that is really core to the security model of Flux. So Flux lets you do multi-tenancy, right? Kind of back to the very first slide where we were talking about why we do GitOps. GitOps solves a social problem, right? I'm working with my coworkers, we're collaborating on these change sets in Git so that we can add context and maybe have a hope in 3 years of remembering what the heck we did when we added this weird Nginx flag to the Nginx controller, and now we're needing to migrate it to traffic or something, right? And so I really don't want to be in an app folder and have too much permission to do damage to the cluster. I need to be able to drop permission. So on a customization, if there is a service account name configured, then we're going to make sure that the Kubernetes client that we use for reconciling that customization and adding those resources to the cluster impersonates that service account. And we do this with a specific Kubernetes feature that you need to have permission to use. The Flux controller is basically God in the cluster, and it can impersonate the list of things that you tell it can impersonate, which is usually everything, but you can restrict the list with resource names if you would like. And if there is a kubeconfig, and instead we are actually reconciling to another cluster in a hub and spoke model, then we are going to configure the client appropriately. And that can also be combined with service account impersonation, but it will be bound to whatever the namespace is in the destination cluster. And then we use the package runtime shared library or cost Flux to make sure that we construct this client in an appropriate way and do it securely. And this is how we make sure that across Customized Controller and in Helm Controller, when we're passing clients around for the SDKs to do things, that they're not getting polluted by some controller state. It's always bound to the permissions of whatever the resource in that namespace is supposed to have. And so that's how that works. Now, when we are reconciling things, there's a couple things to know about working on a resource in Kubernetes and writing a controller. Anytime you want to be sure that you are reconciling a resource, you need to know what version of it you're working on. And so Kubernetes uses etcd to have a consistent understanding of what version of that object it is. And it does this internally in Kube API server in the storage layer. Now, there's a little trick that you get. Every custom resource definition, which all of the Flux API types are custom resources, they implement object meta. And object meta gives you metadata, it gives you a spec, and it gives you a status. Whenever you update the status, you will get a new metadata generation given to you on that object automatically from the Kube API server, right? So if I run a patch and I change a field from false to true on my custom resource in the spec, it'll become a new generation. And so when you write a controller, you need to track what the observed generation that you have reconciled is on that resource, right? So if I go to the Flux UI, and I go to my favorites, maybe. Let's just open up pod info. This is a simple Helm release. There's a specification. And say I change this, right? Timeout, I set 15 minutes. Right? When I give this to the Kubernetes API, in the metadata section, when it writes it to etcd, it's going to always update generation for me. And then in the status, when Helm controller works on this, you'll see evidence of it tracking what generation it's working on, right? So here there's observed generation, and then we also have this last attempted generation. We actually need 2 fields here because the Helm release is kind of a complex state machine. And then even in the conditions, these observed generations for these conditions has to independently be tracked as well, because a Helm release can represent the status of not just one thing, but many things. It could be the hooks, it could be the tests, it could be a rollback or a version of a thing. The Helm is an incredibly imperative tool, and there's all kinds of strange things that can occur when you hit error states when you're installing charts. We'll look at some of that code in a second. But back to the slides. Oh, yeah, there's a note here on drift detection that's based on field ownership. Just a little bit more of like how we deal with like tracking what we're working on. I don't know, it's just kind of out of place. Probably should have put that on a different slide. So also when we're reconciling an object, we need to report what the heck is happening. There is a whole spec. Actually, I should probably look this up and show you where it is. Case status spec. Wait with case. Nope, that's Helm's docs. CLI utils readme. Here it is. So under CLI utils from the Kubernetes SIGs org, there is a package called kstatus. And this kind of lays out what it means for a Kubernetes resource to be reconciling and then communicate what is happening with it. Right, so when we're looking at, like, say, the status information of this Helm release, there's this list here. It's a YAML list called conditions. This is super small. I'm realizing now. I'll make this way bigger for you friends in the back. Sorry about that. So here, there's a condition. It's a ready condition, and then there's a different condition called a released condition. Right? So whether or not the Helm release here is ready to receive traffic or is considered healthy, and then whether or not the release itself is done, and then you can put a reason in there, which is supposed to be kind of like this human-readable enumeration, as well as a message that's really intended for like user interfaces and things like that, logs. And so this schema is what it looks like to be case status compliant. This is notable because in Helm 4, which Flux 2.8 now uses as default for the health checking algorithm, everything changes, and now custom resources that did not health check before across Helm, they actually get health checked if they are case status compliant. But not every custom resource that's implemented across the Kubernetes ecosystem is case status compliant. With Flux, our health checks and all of our APIs, they kind of are in this style. So if you have Flux resources inside of a Helm release, then now the Helm releases wait for those things. And if you, for some reason, have to health check in a way that is not case status compliant, we give you a different API called a common expression language expression in order to, or a cell expression, to compute what you need to do to have your custom health checks for your weird cluster API thing, or maybe cross-plane or something like that. But, okay. So when we are, say, reconciling a Helm release, or reconciling a customization, or an alert with notification controller, or even a source, just pulling in an OCI repo, when we start working on that thing, we always will mark it. We start reconciling it. We say something nice to the user. That's why using Flux is so nice. When you are in the UI, when you're in the text user interface, you always know what's happening with the particular resource. It's not just like this nebulous condition. It's because everywhere in our code, we're always updating these using the conditions shared library from PKG. Right. Also, all throughout the controller, we are producing metrics. So anytime we do something that we think, oh, maybe an SRE would want to know that that's happening inside of the core of Flux because Flux is managing 10,000 apps in this 4,000 node cluster, right? It's great to have a couple of time series metrics for things like how long did it take to reconcile a customization on average? What namespaces were those customizations in? And so you throw a couple of labels on those time series and you can start to slice it up. Here's how deep the workload queue is. Here's how latent it is, for Helm controller to pull some Helm charts from your super slow V1 HTTP Helm repository, stuff like that. I should probably turn on caching. I should probably up the concurrency or auto-scale that or whatever. You get a great view of all of Flux's communication with, I should have pulled up that metrics dashboard. I don't have time to go sifting for it. You can use these metrics to get a great view of the Flux communication with Kubernetes itself. And then that's how you know that Flux is not slowing your Kubernetes cluster down. It's actually all of your mutating admission webhooks, and because OpenShift is weird or something like that. So notification controller is also then using all of the events information. So we produce a bunch of Kubernetes events. And you can watch what the heck is happening with Flux in that way. And I guess really the tone that I'm getting at is we try really hard to be sensibly extensible. Like if there's an interface inside of your kube cluster, inside of Prometheus, something that can interface with your Grafana dashboard, then we go and we do it. And there's code for that, and we can show you how it's done. And you have a bunch of shared libraries that you can use to build things in your own way. The user interface that I've been using here is the UI from Flux Operator. It's pretty sweet. You can go in, you can make favorites. Flux Operator itself is kind of our project to make Flux go into the future. We've got an MCP server, we've got a user interface, and you can auto-update Flux and do things that make sense at high scale infrastructure. But yeah, I've got my fancy UI here, I got my favorites, I can go check that Flux is healthy. Here's all the components. Here's all my Helm releases. We're running some things. For tuning options, if you're running into issues at scale with Flux, then you can increase concurrency. So like we see people with large clusters running, say, 25 concurrent Go routines for reconcile functions at one time, say for Helm releases or customized controller. You can reduce the polling rate for dependency requeuing, which will help your dependency graphs, especially during cluster bootstrap. Say you have a lot of things that are waiting on each other and depends on. You can turn that down. By default, it's 30 seconds. And that'll make the rollout of a fresh cluster bootstrap with complex infrastructure dependencies much faster. If you want to tell things to chill out a little bit in error conditions to maybe get away from like stampeding, back off and stuff, and the 15 minutes is not enough, you can increase it. Similarly, this is default 750 millisecond retry delay with the jitter, but you can increase that if you'd like, and the jitter will apply. We recommend to people to use webhooks when they can, but it's not always practical, so go ahead and poll away if you need to. Lots of people polling thousands of Git repositories every minute. Naturally, moving to OCI repos makes that significantly more scalable. We have a new feature where Helm controller and customized controller can watch when you have values from a secret and you're trying to read things. If you add this label, then by default, Flux is already going to watch those secrets and config maps and get a metadata update for when they change so that it goes and re-kicks the customization or Helm release. That's depending on those things. So that's a really nice way to improve the mean time to deployment. If, say, your main contract with the developer team is to just have like a YAML file inside of a config map, and then you're managing the Helm release for them and it never changes. And then also, that thing that I mentioned, cancel health check on new revision. I'm really excited about this feature gate because I get to tell a story about people. And so story time. Make this nice and big. This is my teammate. His name is Mateus. He's a very friendly person. And this is just like October of last year. We're actually in the Helm repository. This is where Helm comes from. Shout out to Karen and Scott Rigby and Matt and everyone from the Helm project who are such amazing people who work at a massive scale engineering the needs for many, many people over 4 versions now. Yay, Helm v4. Hello, we're implementing a feature in Flux's customized controller that allows canceling the health checks of an ongoing reconciliation when a new reconciliation for the same object has been enqueued in the controller. So basically what Mateus is getting at here is, he's like, hey, everybody's suffering because they made a typo in their Helm values. They already know that the image is not going to pull because they just changed the format of how their commit messages are written, and now the tags have some suffix. They know the Helm release is going to fail. I just want to commit and just have Flux retry. But remember when I told you that because Helm was implemented as a CLI first, that all of the internals of Helm were built with background context? So this background context means that before you were not able to control the context when you would do a Helm upgrade. If I can type while I'm talking, then that would be helpful. So this client that we're going to pass to Helm, we want to be able to control this. And this pull request that I'm looking at is part of Flux Helm controller. So this is something that we implemented to make this feature happen. But what Mateus is asking here is, hey, can we please work together to update the Helm SDK? Because we can't pass the context. And that means that we can't cancel the health checks that are destined to take 15 minutes. Or in the case of some virtual network functions inside of a 5G tower, you know, with a complex umbrella Helm chart, maybe the timeout is 3 hours, right? And you're just stuck waiting for the 3 hours because you cannot close this thing safely because the context is literally the context of the entire controller that controls everything. And so you just gotta wait. And this has been something that people have suffered with in their GitHub pipelines and in Flux for many, many years. And just shout out to Mateus for making this change. In the end of the day, this is the change that actually went into Helm. He's got a bunch of tests in here. You got to make sure that it works properly, and you plumb it through and provide some new functions to do the same things that you could do before, and then we go and consume those in Flux. And then in the code, we have a feature gate. With a cancel health check on requeue is the feature gate. And so if it's not configured, then we just do things as before when we configure the reconcile on the manager. But if it is, then we wrap the reconciler. And so that's actually that reconcile func from Helm controller. Let's go look at that. I had this in wrap reconciler, Helm release manager. Here we are. And this reconcile func that wraps the reconciler and calls it basically is looking for if there is a wait context for a health checker on the reconcile instance that is currently running when a new reconcile happens for a new Helm release spec change. And that's what allows us to safely stop, say, listening for if a deployment's pods are ready, without also accidentally stopping custom resource definition version upgrade, or running hooks that are doing a database migration, or running tests and things like that. And this is the kind of thing that is only possible and really does stand on its own across the ecosystem. I'm so proud to be standing here like many years later after people like Hida and Mateus and Stefan and Michael, and even like I've touched it a little bit, Helm Controller is in a place where I view it as the declarative way to do Helm. It's really a spiritual successor to the project, and you just have such a strong promise and a great UX with something that is really non-trivial and complex. And I hope that I'm succeeding at least in showing a little bit of not just like the sophistication that's necessary in order to do Helm properly inside of the cluster in a controller, but also the kindness and also just the social interaction that's necessary to make these things happen. You know, these people are wonderful, and it's really a privilege to do this. Different companies, same team. So tuning options. You want Helm to be fast? Go turn on the feature gate. It's new in Flux 2.8. Check it out. The original Flux defaults, they were chosen to work on Raspberry Pis for some of our earliest contributors. So in Flux Operator, we do have improved defaults and some t-shirt sizing for like more enterprise use cases. You can just like be like, hey, I want a medium version of Flux or an extra large version of Flux. Go turn it on, and now you have the ability to scale to your clusters in Flux Operator. We sign everything in Flux. We produce SBOMs. The build infrastructure, you know, Stefan has worked with the GitHub security team to make sure that our workflows are solid. We cannot have a supply chain vulnerability in Flux. It would be a massive disaster. And so all of the maintainers take our build infrastructure, our personal security, and our workflows and how we steward this project incredibly seriously, and that stuff, it continues to evolve, and we're always looking at what's next. I will say we're getting a lot of AI slop right now, so that's something that we are looking at. But the project's really dope. These are a couple of notes that you can get from our security documentation as well. Things about how we do RBAC in the controllers, how we promise that soft multi-tenancy is kind of cool, how you can do sharding, things like that. Cross namespace policies, you can turn them on and off. There's security documentation on the Flux website, fluxdio/flux/security. And you can see how seriously we take the project. And, cool. Lastly, we did something kind of fun. We built a controller a while ago called Source Watcher as a demo for how you could build your own GitOps tools in the Flux style with our libraries, with our techniques. We say that Flux is actually built with the GitOps toolkit. And there are actually a lot of vendors who use pieces of Flux. Like when I was at VMware, they were using Source Controller to feed their own other delivery controller called Cap Controller. And they were putting application builds and application source code into Source Controller to do builds on some Tecton workflows or something like that. Kind of cool. You can do all kinds of weird things with Flux. Even I think Pulumi at one point had built their own delivery controller. We added a new API recently to Source Watcher, which is our little demo, and released version 2 of it. It's called External Artifact. And with External Artifact, you now have an API that all of the Flux core controllers support to build your own way to populate sources into the cluster. So if you would like to, say, read some random YAML or random JSON blobs from a Postgres database and then expose them to Flux in a secure way, we support that. Go and implement External Artifact and check it out. fluxdio/flux GitOps toolkit. You can also build your own appliers. There's previously been like an infrastructure as code controller to do Terraform and OpenTofu stuff. So you could, have Flux, use Source Controller, pull in your stuff from an OCI repo, and then run Terraform apply on it. Get some status updates on it, react to it, do some cool things. There's really cool ways to build your own things. But yeah, Flux going into the future, it's pretty exciting. We've got the resource set templates that are now exposed to you from Flux operator itself, which is not only a great way to install and manage and auto-update Flux, but also a great way to do higher order operations on top of Flux, right? Like if you wanted to automate the creation of tenants, then you can use a Flux operator resource set to template that out. Also make sure that a Helm chart is installed in their things to, I don't know, provision their weird virtual IP, whatever weird infrastructure stuff you nerds are into. I know you've got something that you really want to play with, some like mesh gossiping, OCI repo sharer across nodes on some random port or something. You can go and do that. Implement your weird opinions. We have a user interface. I've been showing you a little bit of that. People are loving this. It's actually really great on a mobile phone. So if you want to pop your phone on the VPN every now and then when you get a page at 3 a.m., you can go and check your favorites and be like, hey, why is that notorious Helm release from that dev team failing again, and then you don't have to log in on kubectl just to see that their service monitor was misconfigured. You can just hop into the Flux status page from the UI and Flux operator. Also separately deployable. And what else was I saying on this slide? Passwordless machine identity, Gitless GitOps, getting away from depending on the questionably dishonest uptime percentage of GitHub status page, and maybe relying on something a little bit more immutable and simple, and a little closer to your cluster in terms of availability and moving your sources into OCI. We've got a bunch of examples in the control plane org on how to do this with salsa build level 3 provenance in a way that actually crosses the air gap really nicely. Chat with us if you want to talk interesting security use cases or strange compliance workflows. And then agentic GitOps. I too talk to the machine now. And sometimes it talks back into me. But yeah, I think there have been many times where I've wasted 4 hours trying to figure out which patch was coming from what branch going into what cluster and what file I was supposed to edit in order to find out how this template was going to change in this subchart of a Helm release. And it turns out that when you have hundreds of clusters, 30 repos, that if you just check them out in your directory and use an agent and then install the Flux MCP server as part of Flux operator, you can get a pretty good read-only workflow and even a write workflow for triggering reconciliations to debug what the heck is happening in your cacophony of chaos. And agentic GitOps, I thought it was a joke. We were dorking around just because MCP seemed fun, and it's actually useful. Go check it out, Flux operator MCP. But yeah, thank you so much for letting me come home to the place where I grew up to have a little side quest and chat to you about why I'm so proud of what we do in Flux and what we do at Control Plane, and why I'm excited for what's coming next. And I hope that this walkthrough of the code shows you just how much respect I have for the thing that we've built over the years. We really do something beautiful with Flux, and I'm willing to have any questions or chat. I love making new friends, and yeah, thanks.
Thank you, Lee. As always, a treat. We've got 5 minutes for questions.
The impersonation thing is pretty cool. I don't think I had seen that before. And so you were showing that all you have to do is to add a service account into the customize CR, if I understood correctly. I suppose there is something similar for the Helm resource, and if so, like how is it shared between the two on the code side?
Yeah, so this last line of code here, where the impersonation code is being created, is using, it's aliased as runtime client, but that's coming from PKG runtime inside of the Flux org. So PKG runtime is just a way to create generic Kubernetes clients. Sometimes they have to have a different shape depending on what you're doing with them. But whether or not like you're trying to get it stapled to a kube config for an apply to a remote cluster or a status check on a remote cluster, or you're trying to drop privileges inside of a namespace using a service account, this is like really core to the Flux security model. We actually even recently added impersonation, I think, to, I think it's image policy, if I remember correctly. Mateus had to do it last year. And it's, again, using those same impersonation primitives from the shared library of PKG runtime. So this code snippet is from customized controller specifically, the one on screen, verbatim, word for word. But you have similar ones. Like, remember when I was showing, I think, might have had the, wrap reconciler here. And then, oh, no, it was actually when I was showing code here. And there was the client. Yeah, so like this is Helm controller stuff, right? And you see that we're creating these Kubernetes clients. And these clients are being created sort of in that same way where when we create the client to actually do the Helm things inside of that state machine, we're using the PKG runtime for impersonation. And that's also with the service account field on the Helm release spec. Does that make sense? That can also use machine identities as well. Great question.
Any other questions?
Hey, I had a question about the support of this. As the company behind Flux CD is gone, right? And then as well, the operator for the Flux is picked up by some other company. And I'm just interested what the support gonna look like moving forward for the Flux, as well as that operator gonna be moved under the CNCF to be developed and distributed for users.
Mm-hmm. Great questions. Weaveworks had to close its doors, gosh, I don't remember anymore. Was it 2021, 2022? And I used to work at Weaveworks. My teammate Stefan used to also work at Weaveworks. Stefan is like basically the project lead of all of Flux. He probably has the most sway. If we have a benevolent dictator, it would be Stefan. We don't, though. We have a pretty clear governance model. You can check in our governance repo. Flux is also not maintained by one company. Control Plane has 3 core maintainers right now, but DeepDeepPy, Microsoft, Kingdon, NASA. We've got a bunch of people involved. Hida is actually at Acuity, doing SRE on Argo stuff, but still contributes to Helm, as well as a bunch of our dependencies, and we are very friendly with Hida all the time. He's one of our great friends. So Flux is made up of lots of people, and it is a multi-vendor project. I would say the biggest, I don't know, it's unfair to Microsoft to say that Control Plane has the most, right? I mean, like we definitely put in a lot of effort. We're building products around Flux. As far as Flux Operator getting donated to the CNCF, I don't think that'll happen. We already have the Flux project. The Flux project has been a graduated project in the CNCF for quite a long time, and it's going to stay that way. And it's really important to us that Flux is open and it's vendor neutral, and that we're not just like changing it in drastic ways. But as a company, I work with Control Plane, who's a consultancy where we need to be scrappy. We do need software that we can change to meet our customers' requirements. And that's a little bit of where Flux Operator comes from. But Flux Operator is also totally for the person with the Raspberry Pi in their bedroom. Like we're never going to lose love for those people. But yeah, I would say the operator and the UI, we're not the only UI in the game. There's Lens, there's Headlamp with the Flux plugin. Somebody just released Flux 9s, which is a Flux-specific TUI that's built off of K9s. It's kind of vibe-coded. We try to be pretty open on the ecosystem page for people who are building around Flux. And we're not the first people to build a product around Flux. Azure has a Flux product. GitLab's got a Flux product. Right? All of these people are selling Flux. And so we're just one of the folks in the game, and we're just trying to do it well. So you can see, here's our UI from Control Plane. Capacitor, its own project. Headlamp, its own project. Lens, everything. Right? And then people just building on top of it. Does that hopefully add a little bit of context? I mean, the project's healthy. We're moving it forward. We've got, I love any time maintainers get employed. right? Like Deepti's situation, she gets to work on Flux because she supports the project from Microsoft's product line. She's full-time on that. So hopefully that answers your question a little bit. But yeah, thanks for it. I think it's important for us to be transparent about this, right? Like open source is a people problem, and we got to solve it the people way. Yeah.
All right. Thank you, Lee. Thank you, everyone. For those who are staying in the room, my good friend Fab Skura back there, he will be up next in about 15 minutes on platform engineering and the power of immutable operating system. Thanks, Lee.
Thanks, everyone.
I think the microphone is working.
Yours is on. Yeah, I think we're good. Yep.
Let me see.
Hello, hello. Thanks everyone for coming. Welcome to the afternoon sessions of Cloud Native Days. We have Fabrizio here. He's going to give us all information about the Immutable operating system. So very exciting. He is a Kubestronaut, golden Kubestronaut, right? Which is all, is there 4 certs now?
15.
15?
15 certifications.
15 certifications. He knows his stuff. So yeah, we'll hand it over to you, and then we'll ask questions at the end.
Thank you. I hope that you can hear me. Thank you for being here. Okay, the problem is that probably this way. I will use my hand. I have the ear that is on the other side. So the topic today is very interesting because we will talk about operating system. Here we are cloud native, but what's behind every deployment and everything that we do on the cloud, an operating system. And I work in IT since a lot of time, so I will give you my intro, but today we will not talk about Kubernetes specifically, GitOps and SRE, but everything that was before. And history is always nice because it trains our mind to rediscover something that is not really obvious, and it's like who is working on infrastructure. When everything works, all is fine. But when something is not working, the people that are working as DevOps engineers, SREs, or whatever, they are always on the point of being called on fire. So why platform engineering starts at Node? Before talking about that, I want to give you my introduction. I am Fabrizio Sgura. I'm a chief engineer at Veritas Automata. We do IT consulting and a lot of things. I am a CNCF ambassador and a golden Kubestronaut. I work since 35 years in IT. I started when I was a child, but it's really a long time ago. It was the 70s. And there were already computers. And you can scan my QR code, and it will be nice to get in touch because I always like to talk also if I like computers a lot. The agenda is the node layer, so whatever is running inside a server, how Linux is important for the evolution that we had in the last 30 years. What is an immutable operating system? Someone here knows what it is? Raise your hands. A lot of people compared to the normal thing. So the immutable operating system is a standard that we should consider a lot when we do things like Kubernetes, because we don't want to put our hands on top of the APT or RPM packages. We want something that is there. We don't touch it. We don't install software. We do that on top of Docker containers or other container images if we use other container engines, or on top of schedulers like Kubernetes. In the past, I used also Apache Mesos. Now it's deprecated, but it's the same approach. Flatcar, Kairos, and Talos are the candidates that I chose. There is already a very well-known word around Fedora CoreOS that was previously CoreOS by Google. I started to use CoreOS in 2014, I think it was, for installing Apache Mesos. And that was, by Google, something that was really revolutionary because you couldn't install binaries. At that point, I did with systemd and spawn a container that was including Python or Go, other tools that I needed. I called it Toolbox. And in CoreOS, it was used for that kind of specific operations where you need to use binaries that are not included inside the operating system. Node realities. Why single nodes? Because at the edge, generally, we have computers that are embedded, like Intel NUCs, or could be a RISC-V, a Raspberry Pi, whatever is an architecture that is uncommon. It could be ARM64, AMD64. Sometimes it is RISC option, But we have a reality that is really not the cluster, but just a node, and still present the operating system. If you work with something at the edge, you will probably know the Yocto distribution. That is something that is absolutely not immutable. It requires APT packages to be updated, and every time that you have to introduce a change on top of the operating system, you are crossing fingers, because you don't know what will be the consequence. On the demo, and I will try to be very brief on the slides because there is a lot to say, but I want you to see how we do the rolling upgrade, the A/B strategy that we can use for this kind of upgrades, where you will have the system completely replaced in one round. Rebooting another partition, it doesn't require a lot of knowledge about these partitions and similar. And yeah, let's start with elapsing eras. So I started again when Red Hat Linux was probably earlier than 5, because my first distribution was Slackware 2. We are talking about 1995, I think. It was on a very old IBM ThinkPad SX 48625, and there were 54 floppy disks. The first 15 were for the operating system. The rest was for x86, that at that time we had no Windows Manager. And when I managed, after 2 nights and 2 days, to install everything, I had that gray background that was proper of the X3 without anything, with the cross, and the right click was having the menu to run the terminal. So we are talking about a lot of time ago. I've been living in the war between Linux and Windows. Now we don't perceive it anymore, because in Windows we can run virtual machines with Linux and similar, but for a lot of time at the beginning, I was living where you had to choose if your career was on Unix operating systems or on Windows. Today, when we have to get certifications, we can do Azure certifications for AI, Foundry, and whatever more, and then we can do AWS certifications, things like LPI certification, Linux Professional Institute. That's a real challenge when we have to choose a specific path for our career. But at that time, it was not that way. So again, here I am more precise on the versions. It was Slackware 1.8. And again, I'm recalling the hardware used. Why it mattered? Because it was freedom. Basically, we were used to use something like Unix operating systems that were proprietary. And the free software, the GPL license that came later, and all the things related to the open source and Linux were really mentioning freedom. I was able to install something and use something that was really free to be downloaded and used. So at that point, I am putting here a lesson learned from serial communication. Today we use 5G networks and similar, but who is coming from the past? Here at this conference, it's always full of people that were working with WISE terminals and TTYs that were very slow. We still need that knowledge, because we use buses for a lot of communication, and sometimes they are fast, sometimes they are really slow, and they require the knowledge that we have from the past. So again, just to do some names about the operating systems that I've been using: AIX from IBM, HPUX, and then True64, because I was really in love with an Alpha power station that I had. And when John Hall did the porting of the Linux kernel and Red Hat distribution to the Alpha processors, I was really happy to use my DEC station with Linux Red Hat. Red Hat 5.2 mark in the history something that is very important, because I think that who have been using Mandrake or the parallel distributions of SUSE that at that time were using, like today, the RPM packages, they are marking a story point where we learned to use Unix better. And I remember that we were using the compilation from source. Today it's not used anymore. But in example, in the certifications that I did for the Linux Foundation on system administration for Linux, there was a configure, make install required to be known to compile from source. That is something that who have been working with that specific kind of technology will remember how much time we had to read the lines and the output of the compilers to solve the errors, more than when we have a struct trace from Java or back from Python. There are distributions that not all the people will probably recall, like Caldera. It was used a lot, and it was derived from SCO Unix, and SCO Unix were, at that time, I remember that I used a lot Caldera as a transition for many customers in the late 90s, it was. Then Ubuntu. Today we use Ubuntu a lot. I have to use it not for preference, because I am still in love with Fedora and the project, but for the companies that are using generally Debian and Ubuntu as servers. When I was working with CentOS in 2012-13 for, let's say, working on a standard of servers, I never liked too much to work on Ubuntu and Debian for servers, but they became better. And today I see that there is no real difference between the distributions or among the whole distributions that we can have. The challenge is more to choose what do we want to do with the operating system. And obviously, when we talk about bare metal and cloud, we have roles and ways that people are working to produce something in their professional life and careers that are challenges, but also walking path for becoming a better professional. And bare metal, really, when you talk to a person that is able to create a local cloud computer, or whatever technology in a server farm, it is really different from a cloud architect, because he will know networks, he will know the layers of the OZ. For like having a lunch, it will be very easy for him to recall all the technologies that are related to the hardware. For storage, it will be the same. While a cloud architect will be just dreaming about something that is composed like the virtual way. And managing server farms with RS-232 and whatever we were talking about, the hardware, will require us to consider that we are more near errors. Again, recalling these kind of activities in server farms will let us think better about the immutability of the operating system. Evolution of technology is present since the 90s to today, is something that really is enormous, especially for infrastructure as code. Let's think about how we did the imperative way until 2010, when we were writing bash scripts constantly. I'm still doing that, forgive me. But really, we were doing that normally. Then a lot of infrastructure as code was out, available, and we had to adapt. But people need to remember that we are coming from something that is developing, programming, setting up, doing a setup. And infrastructure as code can be very useful if we know how to use it and we know the basis. But we have the responsibility to understand that if we don't know how to do it and it works. It's like the old style, if it works, don't touch it. And for immutability, this is important because you don't want to touch the operating system if it works. We have the open source world that is mature, open source, free software, a lot of different terminologies and also disciplines and strategies and philosophies. But let's say that here we are cloud native topic, so the community that was born in 2016 did a lot for the products that we are using. Kubernetes, the CNCF landscape products is full of Prometheus, OpenTelemetry, and there are 1,600, so we will not mention all of them. But basically, this contribution is because of the community, and the community is possible if we share together what we think. So when I'm talking to you, I'm just presenting something that it's not for being selfish and saying, ha ha ha, I am the good one presenting and you are listening. No, it's for sharing, because maybe some of you never worked with the operating systems that are immutable. And some others are better than what I am in this. So interchanging is the only way to get better in something. And this part related to the cloud transition, the part that we have been living with virtualizations, that then came containerization, and finally today, a lot of Kubernetes wherever, at least for what I see, because then there are companies that are still using other systems like native containers, or they use a lot of cloud services, and they don't want to hear about Kubernetes. Kubernetes is not easy, it's complicated. Reason more for why under Kubernetes, if the operating system is stable, you don't have to think too much about that. And then the DevOps culture, now it's being silently replaced by this platform engineering that is including DevOps, SRE, and whatever more you want to add. But basically, it helps to understand people that we have to be a cultural movement, share ideas, share tools, provide help to people that need our services to contribute to the maturation of all the systems. It enabled this platform engineering, the open source will effectively become the enterprise innovation engine. We have been hearing talks about a lot of open source ideas. Earlier there was the Flux CD operator, and I can assure you that it's something that, for who remember, we are waiting for a Flux CD operator since years. Hearing that it's coming out and there is a group interested in doing something like it was for many other products is how we can really progress. Modern practices are really important, like the DevOps culture, then DevSecOps, SRE. Many of us probably don't like the names too much. I personally was a system administrator at the beginning when I started. And when I was programming, I was an analyst programmer. Today, it's a mess. There is a lot of cultural differentiation, roles, and for people to be multifaceting. So they can be in a role one day and then move out and go to another option in the next week. This is good because we are becoming flexible. The operating system, again, is still there. We work on top of it. There are people working for us on the upgrades and similar, but we don't need to bother that much about that point unless we want. And we can focus on other things. So we are able to dedicate our ideas and focus to other things that we like. And also we can change. We can change from the adoption of CI/CD as a DevOps engineer or whatever SRE to being a QA. Why not? I've been hearing Faisal this morning talking about DORA metrics, measuring performance of the people that are working. It's not something that is invading our privacy. It's something that we could use as a feedback to have some points to improve. So all the part that is related to getting numbers from performance and measures from whatever we do is not something to lose the job, to get fired, but it's something to get better. And people are generally scared about reviews and similar, but again, in platform engineering today, we are pointing, yes, to immutable operating system, but also to all these kind of metrics and strategies that are giving us more time. In example, we don't need checkpoints or a lot of change controls tickets to discuss among the team because we have tools that can do that continuous deployment, so-called. What is the future trend? We cannot not mention AI because it's present. It's probably overused, especially in this context when we are talking about Linux. I think that we don't need really AI for interacting among us. We could need AI to find a kernel parameter because there are thousands and we don't remember how to put on the command line something that is related to the VGA controller. And instead of going to the documentation, we could use some faster way. But it's not really different from the adoption of what we did when it was Stack Overflow or Google or just searching the internet. The real point is that there are many people that are using AI to develop, and we are still not ready for that, at least from my personal perspective and experience. The edge device is something that initially we were calling IoTs. It's running something now that is giving the topic of a smart device, not anymore something that is like a sensor sending information, but it's taking decisions. So in example, it's a peer node of a blockchain. Private blockchain, not necessarily something that is related to cryptocurrencies, but it could be related to healthcare or life sciences, taking decisions on top of a measurement from a temperature, but adapting all the ecosystem of a freezer, in example, to provide the right ecosystem for medicines. That is something that will require stability of the software that we run. Another reason for not bother that much about the operating system, especially because if you think about edge computing, but also cloud computing, how many times do you have to change the operating system? Generally, for security reasons, there is something that is exploiting or other problems related to instability, performance, so you need to upgrade the packages. But that upgrade or the upgrades that you have to do could be something that is really putting all the things that you do with edge devices, cloud devices, at risk. And if we put again the AI here, that is not really flexible as we are, to control something that's in many cases it's unpredictable because we did an upgrade, try to ask to ChatGPT about an instability or whatever generative AI, not just GPT, but about an instability that is coming from a behavior of the machine. You get an answer. Then you ask differently, I did an upgrade of this, and you will get another answer. It will say, oh, in that case, thanks for pointing me on that, but it will be for this reason. And then you will add more details until you get to a research that initially produced wrong or incomplete answers. It's like humans. You cannot have everything immediately. You have to progress. So the immutable revolution is a progress. From 2013, I mentioned earlier Core OS. This is the beginning. here there is Kelsey Hightower that before of Kubernetes, he worked on CoreOS. And he was responsible for the security of this operating system. They invented at that time a system for certificates authority that was so complicated that it took 2 days the first time to set up on a cluster of 3 nodes. It was called Tectonic. In 2014, we have the idea of Red Hat and Fedora that started with the OS3. OS3 is exactly where we focus today about operating system and the way that you can do updates. In the demo, there will be no OS3, because I consider that is risky. I will explain why later, because now I want to go to the timeline. In 2020, CoreOS was acquired by Red Hat and given to Fedora. At that point, the Google activities that were done on top of an immutable operating system were acquired by the Fedora. It's still that way. They are using the OS3 way with enhancements. It's not really the same as it was earlier for Fedora, but basically, the NCF did a fork of a project, or let's say a team in NCF. They decided to create the fork of this CoreOS and the operating system that is the material of the demo today, that is Flatcar. Flatcar is a project that is built from CoreOS. It's different. It doesn't use OS3. It uses A/B strategy. And there are others that are evolving. We have a very good project that is also working on Raspberry Pis 4, that is Kairos, and that is a nice, a little bit different way to do the operating system. SUSE Elemental or SUSE MicroOS, that is a little bit less immutable present, are other operating systems that today, in 2026, coming from 2 years ago, they are pointing to the real immutability of the operating system. And this is, again, an improvement in terms of security, efficiency, and scalability. If a node is replaceable and not, you can imagine how things when you have your cluster of Kubernetes or whatever you are running on a cloud provider, and one node is going down and it's replaced by an auto-scaling group, and when it comes out, you have a lot of manual activities. Very bad. But it's quite diffused. So if you don't have that problem, you are quite lucky, because I have seen that there are many companies that are still having the problem of the automation of the bootstrap of nodes. So if a node is replaceable, because I don't have to do activities like configuring the network MTU, fantastic. It's not repairing. What is Flatcar? So I talked about this initial fork of CoreOS. It's an operating system. Here it states that prevents unauthorized modifications. It depends on how you use it, because if you are the manager or the administrator of an operating system and you start tweaking and building your binaries to run them there, you can achieve the result of having it, but it's not the right philosophy. Implementing A/B transactional updates. The word transactional is very important because it's really a transaction. I can commit, see the result, and eventually roll back. It's never something that is not touchable. It's also a complete replacement in the case of A/B. And when I was talking about the OS3, think about layers on the operating system with dependency of an RPM tree of dependencies, and you replace a layer. What will happen when you are at layer 5 and you want to go back to layer 4 because something didn't work? A lot of dependency hell will happen. while in AB case, it's not that way. You will not be able to roll back 5 versions earlier if you don't replace completely the operating system in some cases. With Flatcar, you can. It's not really what you should do, but you can also go there because it's like a hash map of versions. We will see how we can select the versions. For the initial configuration, the big advantage that we started to use when using CoreOS and also the cloud computers was the cloud config YAML file. If you use it correctly with that file, you can do everything. Disk partitioning, LVM, volume groups, SSH keys, users, and many other things, including write files and adding services and additional things that you will need at boot and later. This is declarative approach. It's not imperative. I don't enter the operating system in SSH and perform all the changes. It's already available. And that's very powerful. We will see how Flatcar and Kairos, they have a base configuration file. The Flatcar one is called Ignition, and it has initially a YAML format that is then converted in JSON, but it's just a command line automation, so you don't have to write in JSON, it's better YAML. And we will see that it gives us that ability, the same one that we have with the cloud config. So if we want to install a service, we just do it. In the demo, I will show you how K3S installation is done from the init part. So the node is ready to be used, and you don't have to configure it after it has been replaced in some cases. And the atomic updates are part of this strategy. Here I have 4 subjects. Maybe there will be more in the future. Possibly there are others. In the example, SUSE Elemental is not here, MicroOS either, but the 4 use cases that I think everyone should look at for the current days. One is Flatcar, the immutability is total, and the update method is AB, and it focuses on containers, Kubernetes. So you have a ready-to-go environment. It's not that invasive, so you can also not install Kubernetes and use it, immutable operating system. And it's really good because it's using Ignition, and it's also having a provider for Terraform. So it's very, very well maintained by the CNCF. It's CNCF, it's still not graduated, but we are working on that. Fedora CoreOS is from where Flatcar is coming. It's still using OS3, as I said earlier, enhanced. It's not really those layers only. There are mapping and similar things. It's having a transactional update method, meaning that there is a history on top of the path you can walk back and forward. The focus is containers, not really Kubernetes, because they are also using Cryo as base container engine, so it's optimized for who is using Podman more than Docker or Containerd. PXE and Ignition are the way to configure CoreOS, so it's very similar. Basically, it's not changed that much. Talos, we have, again, total immutability. It's pure Kubernetes, and it's API-driven. I haven't used this demo with Talos because I think it's quite complicated, and also because, for me, for showing you the things, but it's pure Kubernetes. And I wanted to show you that ls/lp is still where we search for many other things rather than the kubeconfig and similar. Kairos, it has AB releases and over-the-air updates. It means that you can have a repository where you can grab a and it will be very similar if you use tools like Balena or Mender from Northern Tech. They are doing something that is over the air at the edge. It's available for edge devices, and the focus is also for ISO images and Kubernetes custom resource definitions. Let's go to the use cases. If we think about the resource-constrained hardware, if you have been using Rancher in Kubernetes or whatever solution that is adopted and promoted by SUSE, this is the typical use case. They have a platform that is called SUSE Edge. You can download it. It's for Intel NUCs. It is very good because if you install all the operating system requirements that they recommend, they don't force, they just recommend, it will become an immutable base for the operating system. Kairos provides these over-the-air updates, and that means that generally, if it's not a big change to the operating system, you will not require a reboot. That is important because reboot means downtime, and in Flatcar, there is no way to change a partition live, generally. So Kairos has also that specific ability of running specific updates, just reboot. For edge computing, also available. I've been using it for Intel NUCs, especially for ARM64. I haven't tried on ARM64. The native integration for containers is obviously something that is very important because if we have everything up and running, you will see how I can just boot the machine, virtual machine, in this case, using QEMU, and I already have ready to go a K3S just available without having to install Kubernetes that hard way. Well, it's an advantage if I'm using the cloud-native technologies. It's secured in generally not just on Kubernetes like this, but all the operating systems are having the same authentication method, authorization, and the access that is provided the Linux operating system, kernel namespacing, whatever related to the security for the users and groups, and the file system, the attributes, and all of that. For Talos, there is API that is also very well set. The management is done without shell access. I will have to enter the shell for Flatcar and Kairos. Kairos also has a nice installation that we will not see because I will do the interactive, but it's by QR code. So they did also by the phone this kind of process for installing the operating system. And everything is supportable with the scalable automation using whatever is your tool, the favorite one that you can use for it. Here, now I go subjects that in the demo. Sorry, because the voice is going up and down, but I hope that you will hear me without hiccup. Flatcar Incubator, it's from October 2024. It is still an incubation project, and it's becoming mature, but it's not really wide adopted. So I suggest that when I will share the repository, you check it out when you are at home, and you run all the commands that we will run. Is just downloading something like images, running QEMU, so you have to have a Linux machine with KVM installed. It's not really hard. We are at the Linux conference, so probably many people here will use KVM. And it's really nice to see how we can start experimenting. The advantages of the project Flatcar and also the Kairos one are that you can integrate with all the good practices. So the GitOps team can use all the tools that are coming like Flux or whatever other things that you can use for producing the installation inside Kubernetes and for your software, whatever it could be on top of Docker. Kairos is a they are working very hard. I met them maintainers in the last KubeCon in Atlanta, and they are doing really a great job for moving to a lot of support. They are still working on Raspberry 5 because the bootloader is different, but all the other models are supported. And if you have a Raspberry Pi 3 that is having, in example, 1 gigabyte of RAM, you will find Kairos very useful because it's not requiring a lot of resources for running correctly. The differentiation here that I brought when I brought this presentation is that Flatcar is effectively focusing on maturity and CoreOS compatibility. Also, I would say that taking a look at CoreOS in the last 2 months, and they are really different now, so the fork is becoming a personal, different approach for the operating system. Here, numbers, it's important to see that when we have Flatcar, Talos, Kairos, Fedora CoreOS, SUSE Elemental, and the traditional approach. The traditional one is very, very long. Here is written in Spanish, but we are in Los Angeles. So, tiempo despliegue, it means how much time you need to provision. And the blue histogram in traditional is enormous. So, they are also fast. You will see how a virtual machine will boot in a matter of 15 seconds. The actualizations and updates that you have for security reason or whatever on Flatcar, Talos, Kairos, Fedora CoreOS, and SUSE Elemental, the green bar, they are a lot. While on traditional operating system, if you use Ubuntu or Fedora, you know appear and you have to confirm, okay, let's do the updates. You could have kernel disabled, but sometimes is compromising the driver NVIDIA that I have. I get crazy once out of 5 times, also if I disable the updates of the kernel. So that is a point of failure. The security incidents in the traditional are intended to be very high. On Fedora CoreOS, compared to the other operating system, the Immutable guys, is also a little bit higher. And the downtime each year, it's higher for the traditional operating system. So it matters to adopt something like a practical implementation of all these immutable operating system. Here, I decided to put something like just a brief command line installation that you can use. It's not really this way. You will see in the demo. We will take more time. But basically, they are really easy to get. It's like getting an ISO image and having it up and running with a shell script, or in case of Kairos, you can build a Docker container image, and on top of that, create your own operating system with a targzip or whatever you want to do. Talos is applying configuration on top of a node IP and creating the installation remotely with the config YAML. Finally, first, 76% of organizations use Linux in embedded devices, including where I work. A lot of embedded devices that are out there, out of the cloud, and they will require always special abilities on top of the operating system. All of this to say that think seriously to promote the adoption of the immutable operating system, because you will be free to do other things, including platform engineering, learning about the new tools, CI/CD, removing all of those problems that we have with the teams for checkpoints and change control tickets. We will have more time. Now, let's go for the fun part. I should have enough time to show you both of the things. Yeah, I will leave the QR code later. I will try to use both hands now. I hope that you will hear me, because now it should be better. This is basically the steps.markdown that you have in the repository that is here. I will put the QR code for more time, but let's go for the demo now that is better because you will see something. So basically here, first we download the Flatcar script to produce the QEMU image, the image itself that is the one of the operating system, some change of permission. I decided to download an old and a stable one to show you the AB update. Yeah, sure. The point is that I would like to use the repository, but use these commands basically to get the executable that we will see in the terminal. So the terminal will be, okay, a little bit more visible. Okay. What I have here, Flatcar folder, have config ignition. I will show you how it's done. The image that will be run for the operating system, a script that is bundled and it's available from the repository of Flatcar and it's part of those wget commands. Then the update, gzip, and a specific extension that is used because we are using QEMU and not the real node version. So here, again, I was grabbing an image with version 4230, and we will promote it to 4459. This is a base config ignition. If you don't see it, I will explain basically, but it's a path with the name of the operating system Flatcar demo. A more complicated one will include my authorized key to have the SSH access like you do in kubeconfig. It's generally produced in YAML, but I translated it in JSON with a comment, and it's ready to go. The Rancher K3S configuration will give me the ability to have the kubeconfig written with the right permissions to execute the command kubectl, and here the K3S install service that will be basically translated a unit of type one-shot, a systemd unit that will download the normal way. So if you have installed K3S, you will recognize this line that is get K3S.io, and that will produce a specific system service that will be started by the installation process. Same for SSHD. By default, it's not activated. We want to activate it. So this is the normal command line that you will use for running the operating system, but I will use a little bit more complicated one, this one, because I want to use the bridge network for SSH and not the normal NAT QEMU. So this should be the line that will open up our virtual machine with the window. Let's go. You see that immediately, Flatcar default, it was partition A, partition B. We just do partition A for the moment. It's the default one. When we will reboot, it will have partition B. Now, the login is skipped because it's like CoreOS. I can become root with the sudo as normal, and I will be inside a totally normal, immutable. It is installing K3S, the K3S service. So after some time to have it completed, we should see that the service of K3S is active and running. That means kubectl or kubectl get nodes I have the nodes here with the version 1.54. That's the one that I did without taking that much time. At this point, we have the operating system up and running. Let's see what I have in the... Okay, there are some comments that I put here if you check out the repo. This comment will give you the root device of the USR partition. So if we run these commands, well, it will be better to enter in SSH, because otherwise we will have to write here. This is the not having the clipboard shared. So I have the IP that is the one that I use generally for my bridge network, the 100.135 user core. Just do this. 135. We have to remove the previous guy. We want to enter, and we are inside our friends. So here we can use this command in example to see what is the disk referred to the root partition, VDA3. Disk is visible with a terminal on the projector will not be very perfect to see a lot of things. Yeah, VDA. You see that here we have a lot of partitions, including the USR A and the USR B. Now the active one is the A1. You can have the B1, which will be the prioritize. We can effectively have the priority. The other part the prompt when you boot the operating the original one. Now we go for the upgrade. I downloaded for the upgrade the OEM extension and also the other Flatcar production updates. So it's just a matter of sending them via SCP here. Again, expanding the virus. The two files, the flat. So we need the core. Three home folder of the user. I have the key that was added in the ignition file, so it's not requiring passwords. And with this, we have the files. Now we can go back to the README file, take this. As you can see, I already burned the value of 4459 because it was the one that I downloaded. I just need to run this command and watch with the journal CTL the result. So start with the command. This connection reset by peer should not be a problem. Otherwise, we will have to reboot. This is because of the network of the building here, because I was doing it 3 times and it was working. So it's just a matter of seeing if we can SSH file. update successfully applied, you see here. So this means that the upgrade was successful. It's saying that it will force reboot in 5 minutes. We will do the reboot manually. So we will exit here and here, and we do the reboot from this part. Now, you can imagine that the default will go to the new version of the operating system. And when we will do kubectl get nodes for Kubernetes, that will be still there, untouched. So we updated the operating system. It's very, very small, and this is not something that I can extend, but I can do another thing. Rerun the SSH. Here, the first thing that I can do is showing you that this is the new version. And the operating system is using now partition B. And the kubectl get nodes is showing still Kubernetes up and running, meaning that we did an upgrade, complete one, of the whole operating system, but Kubernetes is still there working. I have no workload. I should have been creating a pod with the Nginx to show you that it's still the same Kubernetes, but you can try that at because there is no alias. You see here that it's running 62 seconds ago, age 9 minutes, 7 seconds. That was when we installed Kubernetes. This is an example of how we can do that. We still have 2 minutes. I don't know if I have more minutes to show you the part related to Kairos. You tell me. 2 minutes. So I will not be able to show you Kairos, but I will be the process. Building a Kairos, I have in my folder here that you can the Kairos image that I downloaded, the config YAML file for Kairos is very, very simple. You see here that I just used the username and password. It would be an interactive installation. And if you quick code installation on top of that disk, and then again, like I did for the QEMU version, this will be the command line that will boot Kairos. Once it's up, look at how easy it will be to do the upgrade. You will list the releases. It's a text-based list. You will select one with the OCI endpoint that is produced in the list. You will run the upgrade with this command. Once the upgrade is completed, it would require, for this case, a reboot, and you will be able to see the same result in Kairos, just following this README file, or steps.markdown. Coming back to the final part of the slideshow, as promised, here, take the QR codes for the repository. Write me if you liked the result. I hope that you will become immutable. And I hope that you enjoyed. And we have space for 2 questions, maybe.
I mean, we're at time. I know you'll be in the hallway, just so that if anyone has questions, you'll be around still for a little bit, right?
Yeah, sure.
Yeah. So let's give it up for the talk. Yeah, thank you very much.
Thank you.
Testing, 1, 2, 3. Sort of works. Testing, 1, 2, 3. All right. Okay. Oops.
All right, I guess we'll get started. Robert stands in the way of our dinner. Last talk here in Ballroom B. Robert, who's been working with databases since 1983, I guess, well before most of us started writing code. He's the CEO of Altinity and leading enterprise provider of ClickHouse and a regular at KubeCon. This is your first talk at SCaLE. So today is going to be talking about Kubernetes data platform, and if anyone has earned the right to tell the story, I think it's him. So please welcome Robert.
Thank you. Yeah, thank you, Faisal. And yeah, massive shout out to SCaLE. This is the first time I've been at the conference. I've wanted to come here for years, so it's really great to be here. And it's great that so many people work to put on such a great conference. So yeah, I'm going to be talking about what's in a Kubernetes data platform, and by showing you the lessons we learned in building one. First of all, how many people in this room actually run Kubernetes? Okay, this is good, about half. You guys, so if you run Kubernetes, you know Kubernetes has a lot of YAML. And you may be thinking this is going to be a lot of YAML slides. I promise you there's just one. What I'm going to focus on is more lessons, things that are, in some cases, somewhat counterintuitive that we learned about running, using Kubernetes as a data platform. How do we know about this? Well, my company, Altinity, has been working with Kubernetes and databases for now over 7 years. We're a vendor for ClickHouse. How many people have heard of ClickHouse? Okay, that's the usual number. Oh, a little higher than usual. It's close to half. Great. It's a really wonderful database. If you haven't heard about it, you should find out about it. It's really good for analytics. We won't talk much about it, but I'll use it as an example because we built a cloud platform. We do enterprise support for ClickHouse. However people want to run it. Turns out a lot of our users run it at Kubernetes, in some cases at very, very large scale. And then we run our own cloud. So in that case, about half our customers are running on that. We also wrote one of the earliest, in fact, to my knowledge, the first operator, Kubernetes operator that was written for an analytic database back in 2020. If you don't know what an operator is, have no fear, you'll know about it in just a few minutes. And yeah, so I run the company, but as Faisal said, I've been working with databases since the early 80s and programming since the early 70s. So I have a kind of an interest in the topic. So I want to just start out by showing you what our platform looks like. It's called Altinity.cloud. And there's a bunch of different ways you can build this. We've been focused on building a commercial platform, but people build these in-house, so you may or may not have a fancy UI for that. This is the UI we built. So for example, this is an environment. I'll talk about those in a second, but it's got 3 ClickHouse clusters running in it, and you can go in and click things and scale things up, scale things down, make new clusters, take away old clusters, kick off backups, and all that kind of stuff. So this is something, of course, if you use Amazon or Google, any of the database services, you're pretty familiar with this kind of interface. I think we just, hang on. I think we just accidentally flipped over a slide. Oh, this is interesting. A slide disappeared. So that is the first time this has ever happened to me. I think I accidentally deleted a slide. But let me tell you what was on that slide. It just was a punch list of all the things that data platforms do. Databases are kind of a pain in the butt to run because there's specialized knowledge required to do it. So for example, how to set things up correctly so that you have a best practices set up where databases, for example, are nicely ordered so that they all fall on different hosts, and if one of the hosts go down, you don't lose all your data. So there's things like that. There's also things that we do that are very boring, like backups, which is something that are, as I'll say later in this talk, are absolutely essential to get right, but nobody really likes to do them. So that's also an important thing that you do. And then we also do things which are complex and require very specialized automation. And a good example of this is upgrading a database. So how many people in this room actually run databases? So, okay, so a lot of you are probably DBAs. And for a DBA, the time when you upgrade a database to do a major version release is a time when you feel real fear, because this is when some of the major disasters happen, that you upgrade something, you either screw up the upgrade process or something bad goes wrong, and then you have to get back to where you were before. Being able to automate that so that it can run, for example, using a round-robin upgrade so that you take database replicas off one at a time and make that happen transparently to running applications, that is a non-trivial problem, and database platforms, good ones, handle that for you automatically. So those are just some of the functions. We're basically trying to automate all the useful things that you need to do to run databases and run them well and allow your developers to concentrate on building cool apps. So one more thing is when we use Kubernetes as a data platform, one of the ways to think about it, this happens to be the way we do it, is that we think about it as organizing it into environments. So for example, in our cloud, you could have an environment that runs in our account for a user, and that's on Amazon. We could have another environment that's in Google that runs in our account, and then we could have environments that are actually wholly within a user's own Kubernetes account in their VPC, and we run there. In each case, we stand up a Kubernetes cluster and we run the databases inside it. So you can think of it as kind of a bin where we can, or a platform that is portable across all these environments that allows us to operate databases efficiently. We'll get back to this question of environments and particularly the question of tenancy in a little bit. But first, let's talk about Kubernetes. So for those of you that don't run Kubernetes and maybe aren't deeply involved in it, what Kubernetes does is it allows you to orchestrate container-based applications. And because this is a Linux conference, I want to say that you're basically orchestrating Linux processes which are talking to storage using networks. Underneath Kubernetes, we have containers which are just built on Linux constructs like C groups, overlay FS, namespaces, stuff like that. So how do we do it? Well, the notion is that you've got something that an application that you want to run, for example, a database with some attached block storage. And what Kubernetes does, the way that it operates, is that we will model that application using resources, or what are called resources. And these are the names of some Kubernetes resources. I'll talk to you in a minute about what they do. But you express those in a YAML file, sort of the definition of these 4 resources. You hand that over to Kubernetes, and what Kubernetes is going to do is it's going to take those definitions and it's going to make the real world resources sort of arrange them so that you actually get a process running on a Linux host with attached block storage, and that this happens reliably. And not just that, if something changes in that environment, for example, the host dies, Kubernetes is smart enough to recognize that something has changed and to automatically bring that process up somewhere else. And it's all based on this definition, which gives Kubernetes a picture of what you want the world to be, and then Kubernetes takes care of arranging the hardware so that it's true. This process is called reconciliation. This is a very, very powerful way of thinking about how to manage applications, and of course this is a great example of infrastructure as code. Now, it gets hard when you actually have real databases. This is a simple one. So I'm taking ClickHouse as an example, but what you have here, the way that it's organized, is we use what's called a shared nothing architecture, which means that the database cluster consists of nodes. These are processes running on different hosts. Each of those hosts has attached block storage. Those processes communicate with each other so that, for example, if you update a table on one of the hosts, whatever part you create or parts automatically replicate to others. We have additional services we depend on. There's something called ClickHouse Keeper that is used to maintain consensus in this cluster. Remember, so that we know that if a part is added to one node in the cluster, so the Keeper keeps a list so that all the other nodes can find out about that part and go fetch it. And then on top of that, ClickHouse, like many databases today, in fact, almost all of them, uses object storage for long-term storage of many different types of data. So when you're building these systems, you have to account for the fact that you'll be accessing object storage. So this is the database. And when we started 7 years ago, we had a problem of, okay, how do we actually model this in Kubernetes? Because the Kubernetes resources are out there, but you can combine them in different ways. And so that was the first design problem that we had to deal with. And this was a long time ago, and nowadays this doesn't seem like a big deal. But at the time, when you're doing something for the first time, you agonize about it. So here's the ClickHouse server. We're just taking a piece of this. There's the block storage. How is it that we actually model this? And what we did was we basically adopted that picture you saw a second ago. There's 4 basic Kubernetes resources that we use. We use something called a pod. That corresponds to a process running in a container. That's the server. The pod is managed by something called a stateful set. That is a resource that knows it is managing a process, a pod specifically. It also knows that this pod has storage. And so it has a way of expressing what kind of storage you have, which turns into something called a persistent volume claim. That is a request. For example, if you want 100 gigs of storage on Amazon EBS, you have a persistent volume claim that requests that, and then may even have some quality of service notations to say how fast the bandwidth is. And then you have something called a persistent volume. That is a resource that represents the actual allocated storage. So this is a modeling that we came up with, and the reason we chose this, the stateful set, is interesting because it does a couple things. The most important thing, though, is that it manages storage. So for example, if your pod gets killed, or the stateful set gets restarted, or deleted, or changed, it is smart enough to go, when it brings the pod back up, to make sure the process gets the storage properly mounted and can find it again. With databases, if the storage goes away, that's a bad thing. You can do other things, like you can increase the size of storage, very common kind of thing. So this is totally simple. If you're using Kubernetes, you probably think, oh, this is child's play. The problem is that, let me see how far we get. The problem is that even for this simple case, it's a little bit more complicated than that. So I showed that database with a couple of nodes. In real databases, one of the problems you run into is those nodes are not always the same. So you may have cases where, and some database clusters are quite large. They may be, commonly run clusters that are 20 nodes or more. We have customers that run up to a couple hundred in a single cluster. These guys may be running different versions of software. These guys may have different we may want to allocate them on different hosts. So there are different, we may want to put them in different availability zones. So as a result, these guys are not carbon copies of each other. They often vary in different and sometimes unpredictable ways. So what we want to do is be able to represent that. And so when we designed the original ClickHouse installation resource, which we'll talk about in a second, it's a new resource that basically has a stateful set for each of the databases that or database servers that we're managing, and then it manages them as a group. But you can actually have them, tweak the definitions so that, for example, you can force them to be in different availability zones, or you can have just one of the nodes be a different version from the others. So this was an early design decision that we made, and this ClickHouse installation resource is now what we call a custom resource in Kubernetes. And it turns out that one of the things that, that made ClickHouse very, very powerful was the emergence of a mechanism for creating new types of resources and adding behavior to the system. So when you're looking at implementing this, when people are building things in these data platforms, there's a couple ways they go about it. One is to use something called Helm. How many people here have used Helm? It's kind of like a package manager. It's kind of attractive because if you've ever used apt or Yum or something like that, I love apt. It's, you know, you just say apt blah or apt install blah and it comes down. Helm is like that for Kubernetes. So it's a package manager, and what it will do is it allows you to use templates to create patterns of these resources. But the other pattern that, and so we'll talk about that, but that is actually not a good way to manage databases for a reason we'll show in a second. The other thing that Kubernetes did about this time that we were going through this design problem was they introduced something called an operator. And an operator gives you a way of, first of all, creating new types of resources. Ours is called the ClickHouse installation, and then the ability to manage them. So to add logic to the Kubernetes cluster, which will manage changes in these resources and do it in a systematic and reliable way. And the way that it works is through the following process. So in the operator, you define the syntax that you permit in your resource definition, and you also have the operator itself, which runs in a container. Everything in Kubernetes is a container. You install the operator, you install the definition, and then you can make these ClickHouse installation resources. You just type up your YAML, you hand them over to Kubernetes. There's a program called kubectl, which you just use to blast them up. And what Kubernetes will do is it will say, oh, I see this resource. I'm going to hand it over to the operator that's responsible for managing it. And the operator gets that resource, and it goes through a process of reconciliation where it looks at what's going on, what are the resources that Kubernetes has defined, what is it this user is asking for with this ClickHouse resource. I'm going to now make the Kubernetes resources look the same way. Those resources then have their own. They don't have operators. They have what are called controllers that manage those, and that's what ends up making the physical infrastructure work correctly. They also do reconciliation, so it's kind of like a turtles all the way down kind of structure. This is a very, very powerful mechanism, and the reason is that the operators. Oh, well, let's first, actually, I'll get to the reasons. I've got 6 of them. Let me just talk about what the resource definition looked like. This is the one piece of YAML I promised you would see. This is a definition of a ClickHouse installation resource, which our operator manages. And the idea is you can see that it's pretty abstract. It's saying that, hey, well, first of all, here's the name of my resource. It's going to create something, a cluster called Argo CD. It's going to have it's going to have one shard. It's going to have 2 replicas. And just by those 2 simple lines, I'm saying, hey, we're going to have 2 servers in this system, but it could also be 100. We have customers that use this that run very, very large systems. We can tell where our consensus is, the zookeeper section. We have additional sections not shown here which specify, hey, what version of the container do we want to have? That's the pod definition. What, maybe where do we want to have it located? What kind of node should it run on? And then the volume claim template, which lays out our storage. There are more things that you can lay out, but the basic idea is you have a pretty abstract definition which lays this stuff out, and the operator is going to turn this into more resource definitions so that your cluster comes up. So the operators do some really powerful things that are necessary. I mentioned that one of the things we're trying to do is handle these complex operations that humans either don't like to do or can't do very effectively themselves without a lot of work. And I'll just pick one example out of these, rolling upgrade. So we have in in analytic systems, it's very common to have multiple replicas for the data. In fact, just about every production system does this. And so the idea is that when you want to change the version of the database, you then have a process that you go through to systematically upgrade those databases one by one. So rolling upgrade, probably, how many people in this have not heard of rolling upgrade here? Is there anybody, how many people have heard of it? Okay, it should be a lot of folks. Well, so what's the big deal here? This just doesn't sound like a very hard problem. Well, there's actually a lot of complexity hidden in this. So for example, imagine you have 24 nodes. Do you want to run them, those upgrades one after the other? Well, every time you upgrade a database node, it would be nice, if you're quite polite, if you waited for the existing queries to finish. So we'll give them maybe a 5-minute timeout, for any ongoing work. That's part of making this transparent. And then we'll drain out we'll basically block it from any further queries. So if we were going to, do an upgrade in sequence, that would be at the very least, in the worst case, 24 by 5 minutes. That's 2 hours. You don't want to be spending that long. So what we actually do is we will run kind of like a canary upgrade. So if we've got a bunch of them, we'll run one, and then if that one succeeds, the process will continue, and if we have a sharded system, most systems this side would be sharded, we'll then look at all the shards and in parallel upgrade their replicas one at a time. So what could have been 2 hours is now a process which will probably complete in 15 to 20 minutes. And there's more to it than that. There's just a bunch of ways you can lose data during this process. Those are not good. So these are all things that the operator handles. And so coming back to Helm charts, so for example, Bitnami, before I guess they got bought out, and now a lot of their open source stuff has been closed up, but they would offer Helm charts to do this. The problem is that Helm just doesn't have the ability to add that kind of logic. So we strongly recommend operators, and I think that should be your default if you're building one of these systems. So that's the basics, but there's actually a lot more after that. Fortunately, this is the most complicated part. So another interesting question is, if you're building a data service, what's your tenancy model? And there's a couple different ways that this can work. One is, and there's really two choices here. Maybe somebody else can think of something else, but these are the two big ones that we see. I talked about these environments, the notion that an environment is a Kubernetes cluster and that's where all your databases live. One way to do it is just if you have a bunch of tenants, in our case they're actually separate customers, but in other cases they might be separate business units. If you're just running it in-house, you could give each of them their own Kubernetes cluster and run their databases there. The other thing is you could have just one Kubernetes cluster and just try and stuff as many of your customers in that one cluster as possible. So this is a really basic choice, and the thing is, if you do one, it's kind of hard to do the other for reasons that you'll see in a second. So for example, if we have dedicated environments, they do have some really strong advantages, particularly for analytic systems. One is that the fact that tenants are fully separated means that they're just running their own clusters. Those are networks that cannot see each other. If you screw up something in one, for one tenant, it's not going to affect anybody else. They're on completely different resources. It's also well optimized for analytic systems because they tend to be large. So it's very common for even medium-sized analytic systems to have 50 gigs of storage, to have many replicas, potentially have a number of shards. Another really key thing is it enables something like called Ballroom Cloud, which I'll get to in just a minute. There are some disadvantages, and you can read, so I won't go through all of them, but just to give an example, if you are building a Kubernetes cluster, it is very slow. How many people here have used EKS on Amazon? So, okay, not too many people. Well, for those of you the 98% of you that haven't, when you allocate a Kubernetes cluster on EKS, which is the OS managed service, it's the next best thing to watching paint dry. It's just very slow. And then there are processes like getting certificates, installing those. So this model is not well optimized if you want to bring tenants on quickly, because you can be talking, the last time I did a big one, it took an hour to come up fully. That was a little unusual. Usually it's about 25 minutes. But yeah, so there's definitely some big disadvantages to this model. Now, you have the same trade-offs with these shared environments. Kubernetes is just not a good place to do true multi-tenancy if the tenants are potentially malicious. So if they're coming from the outside world, there is some pretty heavy engineering that is necessary to split them up. For example, get them running on separate overlay networks, make sure that they can't eat each other's resources. There's also just generally being able to make sure that when a connection comes into this, that if it's for tenant A, it doesn't accidentally go to tenant B. Believe me, because I have experienced it, that is the worst bug that you can have, is like, you know that somebody's coming in and they're seeing somebody else's data. That's when you shut down the system. You say, hey, there's something going on. We think you should come back when we've got it fixed. So the engineering to do that is difficult. But there's some big advantages. And this is why somebody like Snowflake does multi-tenancy within the same network environment. This is why ClickHouse Incorporated, our competitors, have taken this model. It's well adapted for small tenants because the infrastructure is already up. If you bring on a new tenant, you can turn them on almost instantly. And it also, if you take the time to do the engineering, it allows better cost optimization through things like bin packing, for example, or overcommit of resources. So this is a really important choice. And I said that if you pick one, it's sort of hard to move to the other. That is a really key point. That if you have things divided like this, if you want to move people to a different Kubernetes cluster, that's actually quite problematic. Similarly with the dedicated model, actually that's a little bit simpler, I guess, but the migration between these two environments tends to be hard. We picked, for example, the separated Kubernetes clusters. It's kind of hard to go over to the other model and vice versa. There is one more point, which is when you're building a data platform, particularly as a commercial vendor like us, you want to think about how do you let customers have full control of the data. So one of the big, Snowflake, is there anybody in this room who uses Snowflake? Okay, not too many. Snowflake is a really, really great creation, awesome technology, but one of the problems with Snowflake is that if you put your data in there, it's in Snowflake's account, and if you stop paying the bills, your data disappears. And there's, specific, in the terms of service, you'll see a section about how your stuff is gone if you don't pay. Well, most people that have large amounts of data, say 50 terabytes of data, it's very difficult to move it out of an environment like Snowflake. So increasingly, for reasons having to do with self-preservation, compliance, data sovereignty, and just sort of generally being able to have more control of things, people want to have the data and ideally the software that's operating on that data in their own cloud accounts, because then they can't be cut off by a vendor. This is called Bring Your Own Cloud. And this model is used by Databricks. It is a very powerful model, but it's something that you need to think about very carefully. The dedicated model that we use actually is well adapted to this, because for individual customers, what we do is they just give us access to their account, and then we can go create these environments for them inside their VPCs. The engineering is somewhat complex for that, but the advantage of this is it then gives them complete control. They have the compute because all the stuff we run is open source, and they have the data in the user environment, which is what they want. So that's something that was an architectural choice we made about 4 years ago because we were getting a lot of pull from customers, but I think it's the way people are going for large systems. All right, now we get to some shorter items. So if you're running Kubernetes, it used to be you had to run it yourself. That ain't so now. So almost every cloud that you use, except for maybe Hetzner, that's the only one that we use that doesn't have it, but every other cloud has a managed Kubernetes offering. These things are great. I talk about Amazon EKS, that's the one I use most commonly, but we're up on Amazon, Google, Azure. I think we have somebody running Linode, I don't know. These are other, DigitalOcean and Civo are two others. These, if they're there, you should use them. Here's some of the good reasons why, why you'd want to use them. Well, they're integrated with that vendor's cloud, so they're going to work. They do just, Kubernetes is it's kind of like our databases. It's also a pain in the butt to run. Kubernetes, you hear that it is hard. The actual hard part is running it and connecting it to the cloud environment. The managed Kubernetes take care of that. They take care of upgrade, another thing, security. They're surprisingly cheap. The cost to run EKS is about 10 cents an hour. That's, you have to pay for all the other resources that Kubernetes runs on, but the actual overhead of the management is tiny because the vendors want you to spend a bunch, make it as easy as possible for you to fire up a bunch of other nodes. There are some bad things about it. The biggest thing we've run into is that you're forced to upgrade, often when you don't want to. So Amazon will keep, Kubernetes moves pretty fast. Amazon will give you about 1.5 years on particular Kubernetes version, and then they say it's time to upgrade, otherwise we're going to start charging you through the nose. The other thing is broken, these upgrades are not perfect, and broken builds in Kubernetes is a problem with some cloud vendors. Is there anybody from Google here? Ah, good. Yeah, we need to talk to them. We've had more problems with Google. I mean, it happens to everybody that will get a bad build, but occasionally they don't quite get it right. And then everything is different. So each of these, like EKS, GKE, Azure, they all have a slightly different way of allocating systems, so you have to deal with different APIs. But on balance, these things are really, really good to use, and when you're first building a cloud platform, you don't want to have to deal with this stuff. So the thing you do have to deal with is you have to learn to wire these things up correctly so that you can allocate VMs efficiently and so that you can allocate storage. So this basically, and this is where Kubernetes and clouds, where they come together is the part where Kubernetes gets kind of hard, because you have to have the IAM configured correctly so that services inside Kubernetes can, for example, effectively asked to be scheduled on a VM. If that VM is not present, one will be created for you. That wiring doesn't happen automatically. You have to do, there's a fair amount of setup that's required to do that. Same thing with storage. Fortunately, with managed Kubernetes, you usually come up and you're about 80% of the way. You just have to do a little bit of configuration on top of that. Why do you want to get this stuff right? Well, oh, wait a second. What we'll do, as along the way, I'll tell you 2 reasons why you want to get that right. But first, you're running databases, so databases are super, super sensitive to resources. Just some things that we've learned about that are really important. So for example, on Amazon, we're big fans of ARM. They are cheaper and they are faster. So this is, the advantage of ARM seems to be less on other clouds. In fact, I'm not sure that they all fully support them. There's 3 different types of storage that you have in databases, and you need to be well aware of them. We like block storage, cloud block storage, like elastic block storage on Amazon, because if your node dies, you can just reschedule on another host somewhere and reconnect to your storage. The other thing is you can increase the size of that storage with very little difficulty. However, if you really need speed, like if you're doing something where the database is more like a cache, using NVMe SSD, so attached NVMe SSD, gives you really great raw performance. The trouble is, it's tied to a single host. If that host goes down, whatever's on it evaporates. So you better have replicas or have data you don't value. And then object storage is kind of permission to play for analytic databases. Anybody who's storing a lot of database, the thing you have to do in these data platforms is have the IAM configured so that the database can actually write to, has a bucket available and can write to it. And then there's two things you got to watch out for. These are problems that I can tell you from personal experience, both of our customers and more importantly of ourselves. These are two problems you run into. One is, when you ask to do something in the cloud, what's your manager's usual reaction? Cost, yeah, how much is this going to cost? You ask for 16 vCPUs, your manager agrees to give you 4. So this is a really good way to mess up databases, is to have them be under-resourced. In the case of ClickHouse, which we run, ClickHouse doesn't degrade gracefully, it crashes. So having insufficient resources can create just a bunch of problems that you would otherwise avoid. Similarly, when you do actually have a problem, a lot of times, like on Sunday morning, where something breaks, because like you do an upgrade and all of a sudden you need more resources and things are starting to crash, the first thing you want to be able to do in your cloud platform is just scale up the resources. And then go back to sleep, come back in on Monday, figure out what the problem is and address it. But these are really important to be able to do this, be able to, if you're offering a platform, ensure that people don't under-provision, and second, make sure you have the ability to scale quickly up and then scale down when you don't need it. Portability. This is a pretty simple one. I'll give one very simple example. We run across multiple cloud environments, but in general, portability is good because it also means that you can set up this service in multiple locations. Like you can have a dev version of it, staging version of it, a prod version of it. That is easier to do if you don't have a bunch of complicated entanglements with the cloud environment. I'll give you an example. When we first started with our cluster, we used Amazon NLB. It's the network load balancers. They're pretty good, but one of the problems they have is you got to pay for them. It's more network stuff to configure. They each got to have to get certificates installed, and they're slow. So getting one pulled up with a certificate is slow. So we pretty early on came up with a solution to this where we would just fire up the environment. That's slow anyway. We would put one NLB in, and then we would just delegate all the real work of proxying. For example, handling things like server name indications, SNI routing. We put that into something we call the edge proxy. So it goes inside, and then what's cool about that is we go to all these different platforms, and these network operations, which would otherwise be different in each case, are the same. Moreover, we have, we don't have to pay as much for this, and it's faster it allows faster provisioning. That's just one example. There's many ways you can think, but the tendency in Kubernetes is if you can put something inside Kubernetes, that's what you want to do because it's easier to install and manage. APIs. So if you're building a platform, you don't want people to just go through the UI. Although we did that for many years, you want to give them APIs to set it up. There's a bunch of different choices with Kubernetes, and I show a few here. There are things like there's Terraform or OpenTofu if you're using that. You can use Ansible. That's good for setting up infrastructure. There's Helm, which only operates inside Kubernetes. And then there's plain old scripts, bash scripts. They will never die. So there's all kinds of ways that you can build APIs to these. And they operate at different levels. There's some, things like Helm are limited to certain things. Here's our advice on this. Terraform. That's your null hypothesis. Do it in Terraform. And the great thing about Terraform is that you can manage, since you're typically running in the cloud, you can manage both cloud and Kubernetes. What we do is kind of sneaky, actually. We have Helm charts, and so even though I said Helm is limited, we have our Terraform modules call it. If that doesn't work, then look for alternatives, and don't underestimate the bash script. There's a lot of great software that has there's like one monster bash script running it underneath. The good thing about these scripts is that you know what they're doing. things like Helm are complicated to work with. Terraform is, again, can be surprisingly difficult to get work. These things are, you understand what they're doing. The big problem is bash scripts don't deal with stuff like restart unless you put some work into it. HA. This is one of my favorite parts. Yeah, so one of the problems you have with databases is they depend on having data, and sooner or later you're going to lose it. So one of the issues that you want is, so we have our operator, and one of the things, and this is a picture I drew after a failure that actually happened twice in a row with one of our customers, where Amazon EBS volumes stopped responding. This is the absolute worst problem you can have. It wasn't dying, it was simply not responding at all. So you want to have, with an operator, we actually made changes in our operator so it could deal with this situation. And what it was is now with our operator, if your storage gets stuck, you can just go harpoon the volume claim and delete the underlying volume, and the operator will automatically provision a new one. It didn't do that from the beginning. So you need to be able to deal with that. You also need to think about separating replicas. And database replicas, the absolute worst thing is to have them all on one host. Ideally, you want to get it separated into different racks. There's a really important principle called anti-affinity. Kubernetes has very good support for this. It's built in, so we use, for example, this is Keeper, or Zookeeper, which maintains consensus. We use anti-affinity to force these guys onto different hosts. Often, they can also be in different availability zones. So this is something you absolutely want to build in. Backups. I mentioned that they're utterly necessary, and everyone hates them. I ran mainframes myself. In fact, my worst screw up in my life involved backups. It was in my first job. And the problem with backups is there's a lot of requirements. They're used a lot of different ways, and no single method covers them all. So everybody will say, hey, do disk snapshots. They seem like they're easy, but for example, what if the thing you're trying to restore from the backup is a table? Well, that's actually not so easy with disk snapshots. So there's a number of issues. Our own experience, and I think this is common for most vendors, they will not talk about this, but backup failures are a major source of alerts internally. So we have like a meeting every month where we look at, okay, what are the new things we learned about how backups can fail, and we try and fix them. The other thing is they're costly, because if you make a full copy of storage, you're going to put it somewhere else. You can't just keep it hanging around. It needs to be somewhere further away. So it's a source of cost. So you need to think carefully about how you manage that and get it to the cheapest place. And speaking of cost, that's something to pay attention to. Network transfer. How many people have dealt with network transfer costs on clouds? Okay, so the rest of you just don't know how much you're paying, probably. So this is an example of the recommended architecture from most cloud vendors, that if you're running a database like ClickHouse, you have 3 nodes. These are replicas. We've got a 3-node ensemble for keeping track of the cluster state, and we split it across 3 availability zones. And we have end-user applications who are talking to this, as it turns out, through the open internet. Well, so you can see these network connections. Let's translate those into costs. These red arrows approximately correspond to all the connections that cost you money. In Amazon, every gigabyte you move across AZs is going to cost you 2 cents. If you do a lot of rewriting of data and moving data back and forth, that gets expensive really fast. Pulling data out to an end-user application that's across the internet costs you 10 cents a gig. You may have discounts but this can cost you serious money. We're not a big company. Last year, this cost us in excess of something like $600,000-$700,000. It's something you have to watch, and it was one of these things where, when we realized this was happening, we felt pretty dumb. It probably won't happen again, but it was not a good experience. It does lead to an interesting conclusion, though, which, you know, you see these multi-AZ application architectures. Our experience over the last 7 years is that model is probably wrong for most deployments. And here's the problem. To spread things across availability zones, which is to say across data centers, it adds complexity to the applications. That's a big issue because you're running them, you have to force them apart. It adds cost, as I just showed you. It's harder to manage. I mean, there's just more logic required to split things out. So, and on the cost, for example, if you have things like load balancers, you have things like networks, there's actually infrastructure that you pay for, and instead of allocating them once for a single availability zone, you repeat them across different, you know, as many availability zones as you use. So that's how the costs add up, in addition to the network transfer, and that's why they're also harder to manage. There's just more stuff. The thing that's kind of surprising, and this is where, is in our experience, running hundreds of clusters over 7 years, we've never had a failure of an AZ. We've never had a failure where having extra copies across an AZ, across multiple AZs helped us one bit. What happens is that when clouds fail, they fail by region. And on top of that, for the data platform, the last big regional failure we had was one that brought down the US services in US East 1. And what was kind of interesting about it was the big service that it brought down was Okta. And some of our customers use Okta, and so they couldn't get into our cloud management plane. But they weren't complaining to us because the reason was that they were using Okta for everything else. So it wasn't just us down. Every single thing they were running was down because Okta was not working. This is how things really look, at least in the normal failure cases that we've seen. Multiple AZs don't do anything to solve that problem. And so as a result, if you're building these systems, I think shooting for single AZs, I think one thing that we do think is important is to try and get processes separated so they're in different racks. Amazon, for example, does have ways to do that. We're sort of learning how to use that effectively, but that seems to be the best solution. Last time I did this talk, there's somebody in the crowd that, you know, said, but, you know, like, what if there's a war? Has anybody been following what's going on in the Persian Gulf? So, United Arab Emirates and Bahrain, 3 AZs have been taken out of service because they were hit by debris from missiles, as far as we can tell, at least as far as I know. So that's an availability problem. And so the question is, would that be helped by having additional AZs? And the answer to that is still no. And this is actually a quote right off the Amazon Health Dashboard. You can read it right now, assuming they're still bringing these guys up. But they're saying everybody in the Middle East move to a different region. You need cross-regional DR. That's what's really important. And that's actually a hard problem to solve. So final question. For building database platforms, you know, this is talk about database platforms on Kubernetes. Do you always have to use Kubernetes? This is a question I used to ask a lot because I didn't understand how Kubernetes worked. But in fact, the answer is no. You know, there's other ways to do it. And I just want to mention one that is popular. Some of our customers use it. It's called Slurm. How many people have heard of this? Okay, all right, good. So you guys are doing HPC? Yeah, okay, I see some nodding heads here. Slurm, simple Linux utility for resource management. If you run high-performance clusters, you'll have, like we have one customer, they have literally thousands of racked systems, and they use Slurm to allocate these to build things like database clusters. Slurm is, aside from having the coolest name, I mean, it's a name that you want to try it, but it doesn't even use containers. It's basically allocating, you know, sort of slices of Linux machines out to specific processes. It's very lightweight. So it's simple. It runs on bare metal. Bare metal is great because things, you know, tend to be more stable because there's less stuff in the way. It's really fast to spin stuff up. Things that take 15 minutes for us on Kubernetes to allocate new VMs, and Slurm, they're up in seconds. It's very, very tempting when you see it. And the final thing is Kubernetes has there's a number of downsides to using Kubernetes, but one that people aren't aware of until you run database for a while is it runs on liveness checks. So Kubernetes will do checks on your pods, and maybe something like going in on a database and doing select one. If your database gets overwhelmed, it may not respond to that. Most databases don't have good resource management, and so they can't allocate resources that will stay protected when the database hits 100% utilization. And in Kubernetes, what Kubernetes says is, hey, these are cattle, they're not pets, and it just kills it if it's not sure what the state is and restarts it. That's not something you want to do in databases. Slurm doesn't do that. So that's another, like our friends who do financial services, they want the highest possible availability. They don't want stuff like that in the way. So yeah, always think about alternatives. Don't follow the herd. All right, so what have we learned? We learned a lot. I mean, we knew zero about Kubernetes when we started this. We could spell it basically. But yeah, use operators. Pick the right tenancy model. There's really only two choices. I think, interestingly enough, we may go to doing our own Kubernetes management, in the future, because there's some, if you run enough of them, then it begins to, you may have some advantages in taking that stuff in-house, but in general, managed Kubernetes is the key. Terraform, whether you like it or not, thank you, 10 minutes ago, so we got time for questions. It's a null hypothesis. If you want to do the best thing for your users, obviously if your users have different opinions or you have specific knowledge, it might be different. If you don't do anything else in this list, get backup right. It's the thing that people screw up, and there's nothing worse than having a system lose its data because your backups are messed up and you didn't notice. I actually worked in a company where it turned out that for a period of something like 6 weeks, all our backups were being written literally to dev null. And they had a failure at some point, I think during an upgrade, which is also another time that's kind of a trying time for DBAs, and that's when they discovered they had messed this up. It was, I was just like an innocent bystander when this happened, thank God. But that's one you got to get right, and it's the multi-AZ developments or deployments, I think they're way oversold. I think the conventional wisdom actually is very convenient for cloud vendors because it encourages transfer costs. And then Kubernetes, it's great. I love Kubernetes. I think the advantages include things like portability, the fact that actually if you've got it set up, it makes life easier for developers of distributed applications. Kubernetes is not hard as a developer. It is hard as an administrator. But it's also not the only choice. And there are reasons why you might just do simpler things, like just run them on plain, run your clusters on plain instances. We have a lot of customers who do that. Run them using, like proprietary or, sort of local VM technologies, so on and so forth. So that's it. Thank you very much. And if you think you can do this better than what you heard here, we want to talk because we're hiring.
All right, time for questions.
Thanks for the thanks for the talk. Very insightful. I have one comment and one question. So one comment is about if you are using either multi-AZ or multi-region, you probably don't want to rebalance on the network, but you want to rebalance by pulling from the S3 or the block store, the object storage. It's Druid. I run Druid on.
Absolutely right. Yeah, that's a really important point.
I don't know much about ClickHouse, so I run Druid. So in Druid it's possible. I don't know.
Yeah.
And the other question is, So you know that databases all the way from Oracle Rock and others always had, like when it's distributed, always had clustering implemented within the database architecture. I was wondering what's your take on, let's say I'm building a new database, okay, that is after Kubernetes already exists. How much of the networking and clustering would you rely on the Kubernetes stack, or you saying no, it's too specialized and I'm just going to do orchestration and and those kind of things, but not like networking.
Yeah, I think that okay, so first of all, I want to just say your point on S3 is really important, and I underemphasized that when I talked about the 3 different types of storage. What we're increasingly seeing is that data, it's not just sharing data, within a single database, but also adopting things like Iceberg, which allow you to share data across multiple databases. And having this built into your database platform so that, for example, you have buckets in known locations that are just configured for people with appropriate authentication and authorization is really important. Yeah, to this question about clustering and what's built into the database. So, yeah, that's an interesting question. The clustering part that involves scheduling resources, you can completely delegate to Kubernetes. So it used to be, before Kubernetes, databases would be forced to perform those functions. That was something that had to be built in because there simply wasn't external infrastructure. And Kubernetes does a very good job on that in general. Let's say you'd have to be very expert to do a better job. Where the part of clustering that has to stay inside databases, and I don't think is going to move, is consensus about data and operations in the database. So we use ClickHouse Keeper. ClickHouse originally started using Zookeeper, like a lot of people, like Kafka, for example, or I think Druid used it as well. That part is always, I think, going to be part of the database. You can't really delegate that. And that's important because it goes to consistency of data. Kubernetes doesn't know it doesn't have the mechanisms built into it to do things like leader election. That's there's a lot of operations which are unsafe to have multiple people try to do them at once. You have a consensus manager that allows you to elect a leader. That one leader will then make a decision on behalf of everybody. So I think that's my take on it. If you have a different one, I'd be interested in hearing it.
Thank you. Excellent talk. Yeah, just a quickie. So you found yourself in a situation where you had a problem that you decided to solve by writing an operator. How was that effort as far as developers and getting that thing working? Did you find it was easy to manage, or were there complexities? I'm curious how that all went.
Oh, like what kind of problems did we have in implementing the operator? Well, yes. We are very slow to do development, so some problems were avoided by the fact that our lead developer is a just so guy, and like he's, as a manager, I find it a little frustrating because I want stuff like in 2 weeks. He says, okay, you might get it in 2 months. So we're kind of slow and things pretty thoroughly. I think the things that caused us issues were I'm going to name 2 things. One was limitations in Kubernetes itself. We still have a problem with liveness checks, which I think is sort of on us, that we haven't put the engineering effort into designing a liveness check that will not come back, and that will not come back negative just because the database is kind of busy. We should have really dealt with that problem better. There's also limitations in the way resources are managed. So, for example, Kubernetes has this notion of stateful sets, which can have replicas. They have some built-in limitations about the kind of changes you can make inside of pods, and more importantly, the changes that you can make on storage. So, for example, we used to have to respin pods to be able to make a change in the size of storage. So that's something we've worked around. We've now taken away the responsibility for storage management from the stateful set and given it to the operator. Beyond that, bugs. I think the single worst one that we had was there was an upgrade bug where during an upgrade there would be a brief period of time where our nodes would lose track of which shard owned which data. And that because the load balancing got screwed up, it was just a bug. It was like the bug of the year. It took weeks to figure out why it was happening. So some of these things they're just difficult to test. I think that one thing has worked in our favor or worked in the favor of the operator is we do run production systems on it. When you have mistakes like that, let me tell you, customers, they get pretty pissed. So we do everything we can to avoid it. I think having that pressure on us has been really helpful. But those bugs, we've had a few of those bugs. They require a lot of testing. They're often not visible outside of production data. So that was an example of something that was a real problem.
Thank you.
Welcome.
Hi. Why do you discourage moving from shared cluster to dedicated cluster earlier in the slide?
Oh, can you repeat that a little louder? I can't hear.
Oh, why do you discourage moving from the shared cluster, shared tenant to the dedicated tenant?
Oh, yeah. Actually, I think it's a choice. I think it's an architectural choice. I'll just flip back to the. Yeah, it's really a choice. Like, what are you optimizing? There's. Yeah, here we go. So when you have a dedicated cluster, it is, for something like an analytics system that might have a petabyte of storage, it's actually kind of convenient to have it for a number of reasons to just put it in its own Kubernetes cluster. The overhead of managing the Kubernetes cluster is not that great compared to the overhead of managing the database cluster itself. So the balance shifts to, and it solves a lot of problems for you. You don't have to worry about noisy neighbors. You don't have to worry about accidentally connecting to the, like customer A to customer B's data. So that's really good. But if you want if you really want to have highly optimized usage of resources, putting all the tenants together in a multi-tenant system is a better answer as long as you can master the engineering to keep them separated and also get full advantage from reuse, from sharing resources. And the trouble is once you've done one, it's kind of hard to do the other. They're quite different models.
Well, I can imagine it could be a common use case. You start as a shared tenant because you don't need the dedicated tenant.
Yeah.
And then at some point, your company gets too big.
You're absolutely right. And as far as I know, our main competitors, what they end up doing is, what they'll do is, well, even they have because they do the shared model. The trouble is that this is a question we debated quite a bit when we were making this decision. And we decided that it was just simpler to optimize for people growing in place as opposed to having to go through some migration. Migrations of data are really hard. And again, that requires engineering. So what would happen is if you had somebody who outgrew this environment, you would then have to have some engineered migration process that allow them to move. Because this is a production system you're moving, it needs to move without downtime. So that's not easy to achieve. So anyway, I think that's something you balance when you build these systems. And that's why I think you probably make the choice up front and then don't deviate too much from it.
Okay. Any other questions? All right. Well, thank you, Robert.
Yeah. Thank you very much.